Welcome to NX University 2024, and welcome to the first presentation of the event here. We'll be taking a look at what's new in NX Design, CAD-related topics. This is going to be covering two versions of the software, NX 2312 as well as NX 2406. So my name is Michael Pinto. I'm an application engineer and an instructor here at Swoosh Technologies. I have over 25 years of experience designing products in the aerospace and consumer goods markets. A couple of companies I have worked at in the past are Pratt & Whitney and Nike. I do enjoy teaching and supporting customers like yourselves in your pursuit to achieve the best possible designs while using your Siemens software products. My areas of expertise are in 3D modeling, advanced surfacing, freeform modeling, model-based definition using PMI, assemblies, drafting, sheet metal, and stage modeling, amongst many other areas of the CAD-related design side of the software. Getting into a look at our agenda here. First item we'll look at is NX Sketch. Then we'll be looking at the NX Core Design Enhancements, followed up by NX Assemblies. Looking at our first discussion here with the NX Sketch-related topics, we'll be taking a look at the new Sketch Slot command, Silhouette Curve. We'll also be looking at Sketch Create Dialog Enhancements. And finally, we'll take a look at the new Sketch Navigator introduced in NX 2406. First item we'll look at related to our sketch topic is the Sketch Slot command. This is going to allow you to create slots in a single step with the new Sketch Slot command. This new functionality was introduced in NX 2312, and this is going to allow you to construct orthogonal or angled slots very quickly inside your sketch designs. You can select the preview dimensions to keep those while in the slot command. This will create persistent sketch dimensions after you select those. It also creates the center line as a reference curve if you'd like that. You have the ability to lock the length, the width, the angle, and stamp the slots. Dimensions can be created automatically when you are doing a stamping operation. Options to automatically create reference curves are available as well. There are two interaction modes available with the slot command: 3-click slot, or push and hold the MB1 to create center line drag for the width of the slot. Taking a look at a quick demonstration of this process. We'll start out inside of our NX 2312 here, and this was introduced in NX 2312, so if you have that version, you'll be able to use this capability. Inside of our new sketch here, we're going to click on the slot command. That's under the curve, more drop down, slot command. We can easily click and drag to create the slot length. Click a second time to define the slot length. And then click a third time to define the slot. Creating a second slot down below. We'll go through the same motions, one click, a second click for the width. And to create a sketch dimension that is persistent, you can click on those preview dimensions that show up, and that's going to create that persistent dimension. Finally, we can tie this into the X and the Y axes here to fully define the slot inside of our design. Going back up to the more drop down, we'll enter the slot command one more time here. You also have the capability to lock the length, angle, and width dimensions here. If you check those boxes, you can see it's automatically locking those values that have been put into those input fields. And now we can go ahead and stamp this slot into our sketch design. Bring your cursor over and left mouse button click to stamp the slot into the environment here. The slot is created inside the sketch. All the dimensions are persistent dimensions that have been created here. Note the variables will remain the same as long as that lock box is checked over there. We can edit those variables if we want to change those values, and I can bring my cursor back over and place or stamp another slot inside my sketch environment here. Once I left mouse button click, it stamps the slot, and I can also have the ability to create reference geometry if I'd like to do so. So slot geometry can also be created as that reference geometry as long as you check the box here inside the settings, bring your cursor over, and left mouse button click in the graphics display. You can see all the curves have been created in reference curves. That is a new sketch slot command introduced in NX 2312. Next item we'll look at related to our sketch commands, the silhouette curve command. This was introduced in NX 2312, and this is going to allow us to quickly project silhouettes from 3D geometry into our sketch plane. The new sketch command allows you to create silhouette or shadow curves inside your sketches. And this new silhouette functionality allows you to project silhouettes of entire bodies or faces. There's an option for associative projection and an option to optimize curves during creation. The silhouette curve command is going to be inside your sketch tools, and we'll go ahead and take a look at that in our demonstration here. All right, this is the sketch silhouette curve command introduced in NX 2312. In this particular example, we're going to go ahead and create a sketch here on this plane. And now we're going to go ahead and take a look at the silhouette curve command. Up on the curve group here, we'll click on the silhouette curve command. And we'll use our selection filter here to help us select faces. And in this case, we'll choose body faces on the drop-down. That's going to help me select the faces on the body that I want to project from the silhouette curves from, I should say. So I pick one of these faces here. It's going to pick all of the body faces and grab the edges and project those into the plane of the sketch. I'll select OK once I've completed that. And now we have the silhouette curves from the body that we chose. We can add some additional sketch curves, and we can relate those to the projected silhouette curves. I'll go ahead and create a circle by 3 points here. And we'll go ahead and make that tangent with the silhouette curves by using the tangent relation inside of the sketch solver here. Next, the diameter dimension is going to be added to the circle. We can click on the circle, click on the dimension, type in a new diameter value here, and then hit my middle mouse button to complete the operation. Once I've created the circle, I'm going to go ahead and finish the sketch. We've created that direct relationship with the silhouette curves. And now that we have those silhouette curves inside of our sketch, we can adjust the parent geometry. In this case, we have a move face command that's inside this particular part. And when we adjust this move face command, we can edit the displacement here from 0.1 to 3 and change the design. And note inside of the sketch, our silhouette curves have updated and our circle is maintained its tangency with the silhouette curves. So we have that tangency relationship we built before that has been maintained. And this is the benefit of creating these silhouette curves or using the silhouette curve command inside your sketch tool. Next item we'll look at here is the Sketch Create dialog. Sketch Create and Reattach dialogs are now the same, highly requested by customers. And this was introduced in NX 2406. This allows me to, on the Sketch Create operation, I can also use datum planes. I can use the Create Datum Plane function here. This has been reinstated inside this dialog box when you create your brand new sketches. The plane method can now be set to new plane. I can define a brand new plane if I need to do that when I'm setting up the sketch at the time of creation. This is a customer default setting. You can turn this on under Sketch General Session Settings and create sketch method, go into automatic. And you'll see there are two options for the create sketch method. There's an automatic and a manual. You'll want to go ahead and set this to manual, and this is going to give you the advanced method to define a plane, orientation, and origin while you create your sketch. So let's take a quick look at the demonstration for the Sketch Create dialog enhancement here for NX 2406. All right, so we're going to go ahead and get into our sketch tool here. So we'll activate a sketch. Now you'll note the Sketch Create dialog before this enhancement, there is no option to create a new plane during the creation of the sketch. You have an option to create a sketch on a plane or a path, but there is not an option to create a brand new plane while you're creating this sketch. So you would have to pick on an existing plane here inside the part or a planar surface on the physical part to begin creating your planar sketch inside the design here. You would select the horizontal reference. This would represent the x-axis inside of the sketch environment. You can pick on a linear edge or an object or a vector direction to establish your x-axis direction here. The origin method, you would specify that. This would be the origin of the sketch. And you can set that using an origin method options here. You can infer the origin, or you can use a work part origin inside this environment. Once you're ready to create the sketch, select OK. Create the sketch curves inside that sketch environment. In this case, we'll create a simple rectangle here. And then finish our sketch operation. Now we're going to go back in and edit this, the sketch feature we just created here inside the environment. And to demonstrate, if you do go up to reattach, we can use the reattach command to reattach the sketch. And previously, inside the software, you could reattach a sketch, and it did give you the capability to generate or create a new plane while you were reattaching the sketch, as you can see here. So the new plane option does exist there when you use the reattach capability. After activating the new plane option here, you can go in and pick a new plane. So the user can now enable the manual sketch creation option in the customer defaults to allow the capability to create a new plane during the sketch creation process. Under our file utilities, we're going to go into our customer defaults here. Inside of the customer defaults, we're going to navigate through the customer defaults, sketch, general category, and on the session settings tab, you'll see the create sketch method. The default is automatic. That is not going to allow you to create a new sketch when you create those sketches. You want to switch that over to manual. This is a new option here. And once you do that, you'll want to restart your NX session for that to take effect. So these customer defaults, when you modify those, you do have to restart your NX session before you will see these take effect inside this software here. Save any open part files before you exit out of the program. File, and then choose exit. Once we restart NX in our side of our new session here, open up our part file. When we go to create a new sketch, now that we've modified that customer default, you can see we now have the capability to create a brand new plane while we're creating the actual sketch. So I can set my plane method to new plane, and now I can define my plane using traditional methods here for setting up a new datum plane. I can specify the ingredients for the new plane, defining the reference direction, horizontal X or vertical Y, and I can also specify the origin point of the sketch now. So for the origin point, we'll go ahead and pick on the midpoint of this edge here. You can see the preview of the coordinate system there. X to the right, Y going up, and Z coming towards me. Once I'm satisfied with the plane, I can go ahead and select OK, and now I'm sketching on the new plane that we just created at the time of creation of the sketch. New sketch is created, and the user can continue to process by adding curves and then completing the sketch. That is a new sketch create dialog in NX 2406 and the capability to turn on the manual mode, which is going to give you the capability to create a new plane at the time of creation of your new sketches here. All right, the next item we'll look at here is the new sketch navigator. This was introduced in NX 2406. The sketch navigator is going to provide continuous browsing of geometry, relations, and dimensions inside your sketches. Sketch navigator is going to have separate tabs on it for curves, relations, found and both persistent, as well as external references and any issues that might be going on inside this particular sketch. We also have a number of columns here. We have a title column. That's going to be the object type and name. A status column, which is going to be fully defined, fixed, partially defined, relaxed, etc. So this is going to give me the status of those particular items inside of my sketch navigator. Also, we have a source column. What is the origin of the object? And then finally, we have a value column, which is going to show us dimensions and expressions and that is also going to be editable when you double click on those dimensions and expressions. So let's take a quick look at a demonstration related to our sketch navigator in NX 2406. Again, this is the sketch navigator introduced in NX 2406. And here you can see our part that we've been working on in our previous examples. The new sketch navigator will be located on the resource bar like all the other navigators inside of NX. Of course, we have to edit a sketch or be inside of the sketch solver environment. So we're going to activate a sketch here. You can see over in the left-hand resource bar, we now have our sketch navigator that shows up. If you select on the sketch navigator icon on the resource bar, it's going to open up that sketch navigator, and we'll be able to take a look at the different options here now. There are 4 tab categories at the top of the sketch navigator. We have curves, relations, external references, and issues. If we click on any of these tabs, it's going to activate that particular category. And the panel down below is going to have all the related items related to that category. Clicking on the Curves tab, you can see all of our curves. We also have a variety of different columns for each one of those tabs. We have title, status, source, and value in this case. And you can see we also have objects that were used to help set up the sketch inside of the Curve tab as well. We have horizontal axis, origin, vertical axis, and then down below there we have all of our curves inside of that sketch environment. You can expand the plus nodes and see additional information. And we also have a status column here that's going to show me the status of that particular curve inside of my sketch. In this case, this one is fully or non-movable. If I right-click on this curve and we decide to set that to reference, we can now see in the status column that this is a movable curve. If we right-click or we edit that and set that back to a defined or defining dimension, you can see the status of that has been changed to a non-movable curve. So we've added that to a defined, or that dimension has now been changed to a defining curve or dimension, and now our curve can no longer move. We can edit the value of that dimension and set that to a different value just by double-clicking inside the column there. We can edit the value now after it's activated and change it if we need to. On the Relations tab, you'll see we have all of our different sketch relations down below. We have persistent relations as well as found relations that will show up in here, designated by different folders, as you can see, as well as all of our dimensions. You can see the status right at the top if our sketch is fully defined, as well as at the bottom here it still says sketch is fully defined. If you look at the External References tab, this will show any external relationships between the sketch objects with external items to the sketch. We have a variety of different folders here for different topics. Here we can see the sketch placement folder contains references to external items that are used to help set up this sketch. There's the plane, there's a point, and we also have a horizontal reference. By expanding the plus node, you can see the item inside that folder, and there's the direction horizontal reference. The source column shows the source of the external references is within the current part or another part file. As you can see, this plane is within this particular part. Next, we'll click on the Issues tab, and this is going to show any issues related to the currently active sketch. As you can see, we have no issues. We have the green check mark. So this sketch is good to go. And it is fully defined at this point, and so we can finish the operation and continue creating the rest of our design. If you want to reset the navigator button, you can go ahead and click on the reset button up here. It's going to restore the navigator to its default setup, collapsing all folders and tree levels. That is the new sketch navigator introduced in NX 2406. The next item we're going to look at here, our next topic of discussion, is going to be core design enhancements inside of NX. And this is inside of NX 2312 as well as NX 2406. We're going to take a look at part family enhancements, the capabilities for thread feature parameters, selection intent enhancements related to multi-body selection intent for holes, Boolean operations, holes, and thread. We'll also look at enhancements to the clone finding and synchronous modeling capabilities, and then selection intent enhancements with feature curves, supports for group edges. First item we'll begin to look at here is going to be part family enhancements, the capability for thread feature parameters to be added to your part families. So thread expressions are now going to be exposed and can be used inside of part family tables. This is introduced in NX 2312, and this is going to allow for the support to add thread feature parameters inside of your part families. We can add thread standards, thread sizes, radial and gauge expressions, and also renew old thread features to get updated functionality. So if you have existing thread features from a previous version of the software, you can renew those old thread features, and that's going to allow you to add the thread standard, thread size, radial and gauge expressions to your part family members. Continuing with our selection intent enhancements, we have the ability to use multi-body selection intent for holes, for Boolean operations, holes, and threads. This was introduced in NX 2312. Siemens' continuation of multi-body projects now adds a selection intent to the hole command. We have Boolean operations in the hole command that can now support selection intent for bodies, such as single body, feature bodies, bodies in a group. Also, there is ongoing work to support multi-body workflows, and that includes multiple targets for subtract and intersect, multiple targets for unite commands, multi-body Boolean hole and thread commands, such as subtract, hole support for multi-body subtractions, the ability to propagate threaded holes to multiple bodies or targets now, holes support for selection intent with subtract commands. Also, there is feedback for non-participating bodies as well. All right, continue with our Boolean improvements for multi-body Booleans, feedback for non-participating bodies. There is improved feedback for multi-body Boolean operations now. This allows for a Boolean alert for non-participating tools. The alert is going to inform the user that a body did not intersect the target. You'll have an alert that pops up on the display here, and you will also see an alert inside of the part navigator. As you can see with the subtract 5 in that image there is an exclamation point inside the yellow triangle, and that gives you the user an indicator inside the part navigator. You might want to take a look at this feature. One or more tools did not intersect the target. Non-participating bodies will be highlighted in the red color, as you can see in the image on the right. So let's take a look at a quick demonstration of the multi-body Boolean feedback inside of NX 2312. All right, this is a demonstration of the multi-body Boolean feedback. As you can see, we have our part here, which is an assembly, and we have some different pins inside this particular assembly. And we're going to be subtracting those pins from this body here. The non-participating tool body is highlighted in red and the alert is shown. So we can see that pin is sitting outside of the main body. We're trying to subtract all those pins that we selected, but that particular one is not interfering or interacting with that body. The alert column will also indicate non-participating tool body condition for the features. That is multi-body Boolean feedback introduced in NX 2312 here. Next item we're going to look at is enhancements to clone finding, which is going to expand our synchronous modeling capabilities. This enhancement comes in 2406. Chamfer finding capabilities have been added to the delete face command. This is going to provide the ability to find multiple chamfers in a single selection. It's going to improve your CAE workflows for deleting holes, blends, and chamfers. Also, you can find clone block on delete face dialog. Recognizes 3 types of chamfers related to a single selected chamfer. So the exact match type selects the same size and angle chamfers. The loose match type is going to select varying sizes, and then all is going to select all the chamfers on the part. That's going to work without chamfer labeling inside of the program here. So let's take a look at the delete face command. Clone Finder is going to now detect chamfers operation. And again, this is introduced in NX 2406. And our core design enhancements, this is the chamfer finding capabilities. So let's go ahead and use our delete face command here. We're going to pick on this chamfer on the body and the clone or face finder section here. You can see it's finding exact matches for that chamfered surface. We check the box and it's going to select all the chamfer faces that are an exact match. If we choose all, it's going to select all the chamfer faces on the body. And we can delete that off the part. All right, getting into our next discussion here. Topic number 3, assemblies related enhancements. We'll take a look at assembly restructure, constraint retention on copy and paste operations introduced in NX 2312, synchronous assemblies, NX 2312, and then finally performance enhancements in NX 2406. Assembly restructure, constraint retention on copy paste operations will be the first item we look at here. These enhancements were introduced in NX 2312. The copy paste constraint with components capability. This is available as an early access feature, so this does have to be enabled inside the program. The option can be found in the early access features. Option is disabled by default in NX 2312 and can be enabled using the early access feature dialog. It is enabled out of the box, however, with NX 2406. This is going to allow you to maintain internal constraints that exist between your copied components. It allows you to copy and paste into the same or different subassembly. Also, it allows for the copying of this geometry and constraints across windows in the same NX session. This supports all constraint types except for the fixed type, such as touch, align, parallel, perpendicular, concentric, distance, angle, fit, align and lock, center, and the internal bonds constraint types. Paste special is available to copy and paste without the constraints here. So this is a legacy behavior that's been the way that it was handled in the past. If you do a copy and you paste, you can paste that without the constraints if you do the paste special operation. All right, the next item we'll look at here is assembly restructure, constraint resolution on copy paste operations. The guided constraint resolution provides easy method to resolve constraints outside of copied components. It allows you to identify and redefine references outside of those copied components. The guided interaction model, as well as the multiple occurrences listed separately in the dialog, and then drag components while the dialog is open. If you want to use interactive keys on the keyboard, Control plus Alt is going to allow you to rotate while you're dragging the components as well. Show, hide, and replace reference set from Assembly Navigator with the dialog open. As you can see over on the right, there are going to be 3 different interaction or resolve constraints for paste dialog appearances here, and we'll see that in the demonstration in a moment. All right, this is the assemblies enhancement, assembly restructure, constraint retention on copy and paste operations introduced in NX 2312. This is an early access feature. You do have to activate that. Use the finder and enter the search term assembly to quickly filter your results here. And enable constraints resolution on assembly restructure operations. This is the item we want to look at here. You'll see the current state is set to off. If you right click on that, you can change the state to on here. Once you do that, select OK. And now it will be active inside of NX. So let's right click on a component here to open the context menu, and we'll choose the copy operation. We're going to right click in the open space, and we'll go ahead and choose our paste option. Once we paste the component, you can see that is going to be displayed inside of the assembly here. And now we can resolve the constraints. Holding the Control plus the Alt keys while pressing the left mouse button is going to drag and allow you to rotate that component that was placed inside the environment. And the resolve constraints for paste dialog, select the constraint to resolve. In this case, the alignment constraint, we'll pick on the central axis here. and we'll pick on the central axis of the rod here. You can delay the positioning update if you'd like to do that. You can just check this box here. That way the component is not going to move after resolution of those constraints, and we can continue resolving our touch constraint next. So we'll pick the bottom surface here on the hole and pick the bottom or this face here on the end of the rod. Once we uncheck the delay position update, you'll see the component is going to go right into its position. Now we do have a problem here. We have to resolve a conflict. To fix an error condition with the constraint, we can right-click on the constraint and reverse the constraint direction. You'll see the red highlight right there. We can right-click and reverse the direction of that, and now you can see it's going to go right into its position after we resolve that problem. I can complete the operation, select OK here inside the dialog, and now our copy and pasted component is in its correct location. Components can still be copied and pasted without reestablishing constraints. If we right-click on this component, we can copy those. So I'm going to go ahead and copy this screw here. And then right-click. We can go down to what's called Paste Special, and we can paste that inside the environment without having to apply the constraints here. So we can paste without the constraints, and then select OK. A copy of the screw has been added to the assembly. It's placed in the default location where we copied it from. And now we can go ahead and move the component using our Move Component tool here, reposition that inside the assembly, and then we can add our own assembly constraints if we need to do that. So next we'll go to our assembly constraints and locate the screw inside the assembly using some additional assembly constraints here. In this case, we used fit. That is the assembly restructure constraint resolution on copy-paste operations introduced in NX 2312. This is also available in 2406 and 2312. You do have to turn on the early access feature for this capability. Next item we're going to look at here is the synchronous assemblies introduced in NX 2312. This is going to allow for flexible assembly relations that are going to produce desired results without requiring manual redefinition. A single modification automatically impacts multiple parts and reduces design modification time. This is going to allow you to leverage synchronous modeling commands inside your assembly. It also allows for simultaneous modifications and multiple components with a single synchronous operation. Assembly position modifications will produce synchronous modeling edits inside associated parts, and assembly constraints and history-based modeling is taking place here. This is available as an early access feature. This is going to enable shape change when a component is positioned. So when you go into the early access features, you have to go into enable shape change with component positioning, right-click on the off in the state column and set that to on, and then restart your session here. Continue with some synchronous modeling assemblies enhancements here. Label modeling components. As you start to use synchronous assemblies inside of your assembly here, you do have to label a component as a modeling component. This is communicating to the software that you are going to be moving that component in the space of the assembly, and anything that is related to that component at the assembly level will be modified accordingly. So components are rigid until labeled as components or modeling components. Modeling components, the motion is applied from the assembly. Relations found between the bodies. So if you have one component that has a relationship with another component, the relationship is automatically found between those two bodies as long as there's an assembly constraint that's applied between those two bodies. And also multiple instances of the component will also change the shape. Modeling component state does not persist in a part after completing the change. So once you complete that change, the modeling component state does not persist inside of the parts. Changing the work part is going to remove modeling component state. Synchronous modeling or synchronous assemblies continued here with the move command. The new move command, once you go into this synchronous modeling operation, this new move command is going to replace the existing move command, move component command when modeling components are present in the work part. This is going to support dynamic motion using the different handles, allows for precise dragging of those components, and the component motions within degrees of freedoms of existing constraints. So if you have assembly constraints that have been applied to that component between other components, your degrees of freedom will be restricted based on those different constraints that have been applied. This does solve in the active arrangement. It is not available if anywhere an assembly is enabled. Modeling component changes related to this. Explicitly selected faces in the Move dialog will move. Faces moved by assembly constraints will move. And related faces based on Relation Finder settings will also move. Faces implicitly selected to maintain the integrity of the body will also change. Continuing with our synchronous assemblies discussion here, change faces in the feature part. So what happens when you use the synchronous command inside your assembly level? You'll see here that when you use these synchronous modeling edits at the assembly level, this is going to create a change face feature in the part navigator for the affected components. The modeling feature created per change component per move operation. So features can be edited through the change face dialog. Moved faces selected by the user or inferred from the assembly constraints are shown as selected. That means if you do select on the change face feature, that change face 9 feature in the part navigator there, it's going to select or show that on the part and the graphics display. Motion definition is going to be inferred by the solver and can be a translation, rotation, radius, or a complex motion. Translation, rotation, and radiuses are associative and editable, and motions are shown in the change face dialog. So let's take a look at a quick demonstration of these synchronous assemblies inside of NX 2312. So here we'll enter the early access feature. This does have to be enabled in 2312. We're going to search for the term assemblies, and you can see down below we have to select enable shape change with component positioning. That's currently set to off by default. We need to turn that on. You can right click on the state column, the word off there, right click on that cell and set that to on. You will need to restart the session before changes take effect in NX. So make sure you restart NX, select OK here. You can see the notification that discusses that. Restart your session. So we have a compressor assembly here. Some adjustments are going to be made. So we're going to go ahead and grab, we have a dial inside of here. So we're going to go ahead and modify the pressure gauge as the modeling component. Once we designate the pressure gauge as the modeling component, we're going to go to Preferences, Assemblies. You can adjust the color if you want to. So when something becomes a modeling component, you can have that particular color. In this case, it's that turquoise color. The Relation Finder options can be adjusted in the Relation Finder dialog. And now we're going to use our Move tool to move the gauge. So we're going to move the modeling component inside the assembly. The relief port component will be selected in the pressure gauge assembly. Specify the orientation, and we're going to move that component. When attempting to move the component using synchronous assemblies operations, the components affected must be at least partially loaded in session. The user can select the Yes option to load the components to complete the move operation and solve for the changes. Now, note the OD of the dial component has increased due to the movement of the relief port component. This was a result of the assembly constraint that were existing between the relief port and the dial. In order to maintain that relationship, the dial OD was increased in size. Now we'll turn off the offset relation finder settings. So I'll turn off offset here, select OK. And now we'll move our component again. So we're going to move that relief pin one more time. I'm going to grab the handle here. And we'll move that, we'll go ahead and type in 10 millimeters and offset that 10 millimeters along the ZC. Now note, the ID is unchanged here. The OD is increased by 20 millimeters. No, only the OD on the dial component has been increased this time, and the interior wall ID has not increased. Effectively, the 10 millimeter move along the Z vector direction of the relief port component resulted in a 20 millimeter increase in the OD. And finally, we'll adjust the dial connection stem to reduce the length. So I'm going to use the move operation. Click on the move command here. We'll pick on the top surface, specify the orientation, and we'll drag that down or enter a value here of minus 30 millimeters to adjust that face. Activating the dial component as the work part in the assembly will review the resulting features that have been created inside that part. Note inside the part navigator, we have a couple of change face operations here. So these are features inside the part, the dial part. The Synchronous Assemblies operations has created those 3 features. We can edit those if we need to do so, go back into those and modify some variables if necessary, but they are features inside the part navigator for that dial now. If you want to deactivate that component, you can click on Label as Modeling Component on the toolbar here. You can pick a new component. In this case, we can pick the tank, the compressor. You can see the whole body becomes that turquoise color, giving the indication that is the modeling component at the assembly level. Now we'll move the dial this time. Select that component and drag that along the ZC axis here. And you can see the stems have expanded or lengthened for that change. We can make another adjustment here and then select OK. Make a few more adjustments. In this case, we have our box shell. And finally, we can move another component here. So we'll pick on the box, specify the range of motion, drag that down, move that over to the right, select OK, and you can see the stem on the actual compressor has moved along with that. And that is due to the assembly constraints that have been applied in the assembly level between those components. So that is the synchronous assemblies inside of NX 2312. That does have to be enabled in the early access features. All right. Additionally, we have performance enhancements. We now have in NX 2406, Siemens has allowed for faster loading to enhance user experience, improved fine component performance inside larger assemblies when using structure-only assembly load option. This allows for data structure processing that is improved to more efficiently traverse large amounts of data. Also, improve the component or fine component performance by up to 2 times with very large assemblies here, and loading large managed monolithic JT assembly files, parallel loading of facets from monolithic JT files, improve the performance where network latency is present, approximately 25% here, and this works in conjunction with locally cached data to further improve your load times. All right, that is going to wrap up our What's New in NX Design CAD-related discussions here for NX 2312 and NX 2406. Thank you for watching this presentation. Again, here's my contact information. If you need to reach out, you have any further questions, you can email me at my address here. Coming up next, we'll have my colleague John Vincent discussing what's new in NX CAM-related operations inside of Siemens NX software.
everybody. My name is John Vincent, and I'm from Swoosh Technologies, here to discuss with you what's new in NX CAD in the latest releases. And the latest releases are going to be NX 2312 and NX 2406. So we have a number of topics today to dive into for the manufacturing content. We're going to look at a whole host of different topics. Some things that are related to feature-based machining, a little bit easier to use options that Siemens provided to us. We'll take a look at some generic feature operation enhancements, various enhancements in hole-making operations. Those are always welcomed. I know a fan favorite. We'll take a look at some other kind of user enhancements. The fact that we can now get some data on our material removal amounts. We'll show a new workflow for a single blink for toolpath animation, and get into the new relaxed naming rules, talk a little bit about machine-powered programming, and some enhancements across some different operations, as well as some new features, new operations Siemens has provided in these latest releases. All right, so the first one we're going to take a look at is Make Machining Suggestion. And Make Machining Suggestion is really kind of a mask on top of feature-based machining, but making the tools a little bit more user accessible. And when I say user accessible, I really mean that we are going to allow the selections or application of the feature-based machining rules directly from selecting geometry on your part file. So this new option, Make Machining Suggestion, enables you to select a given face on your part and apply the rules that are built into feature-based machining to go ahead and process that geometry or that feature. So now, out of the box, the system may not process the feature in the manner that you desire, so we can just go ahead and interactively add a new process to our suggestions directly through NX. We do need to make sure that our early access feature is turned on to gain access to this functionality. So once we do use the initial Make Suggestion, we can go to the next step of either utilizing that toolpath, that given toolpath, or perhaps we want to embed, our own process into NX and into the software for reuse downstream. In this scenario, we'll see that this pocket was cut in one operation, but very likely you may want to do a roughing and a finishing operation, or maybe even a roughing semi-finishing operation. It's really completely up to you. So what we're going to do is just change up our programs utilizing the geometry that was selected originally by the Make Suggestion functionality. And in this case, we're going to create a pocket rough and a pocket finish operation. We'll change the settings in the operation to reflect the actual behaviors we want to see. And then once we have created both the rough and the finish operation, we'll go through and teach these new suggested methods to the software. So in this case, we can see that we left some geometry on the walls, some material left on the walls of the pocket, and that the finish operation will go ahead and just cut the wall geometry. So as we finish making our setting changes here, we'll generate our operation, and then we can proceed to teaching this new suggested method. So here you can validate what the process is doing. And now we can click on our feature group and capture this new process, this secondary process. And you can certainly do this multiple times. As you can see, this is using the standard machining knowledge libraries. So same things if you are familiar with feature-based machining, same libraries are being used. It's just kind of an easier way to apply them. So now as we add a new suggestion to the menu, we can name it whatever we like. And we have now taught that suggestion to the machining feature navigator, or I'm sorry, the machining feature library. So now we have a similar feature on the other side of this part. When we choose make suggestion, we can use the automatic suggestion, which is going to be the out-of-the-box functionality, or we can choose our rough and finish method that we developed. And we can see that through use of make suggestion, we have now applied those new features to the other, or the new operations to the other feature on this part file. So very quickly, you can see how you can capture and reuse your changes that you've made inside of the make suggestion functionality. Here we can see inside of the FBM configurator that where our rule was created, as well as the fact that we can go in and delete them very easily through our NX session. Currently, we're only allowing single faces to be selected. The features do identify adjacent surfaces to know, are we looking at cutting floor geometry and the surrounding wall geometry. But as we progress further with this feature, we'll see a little bit more relaxed rules in machining suggestions. The next topic is generic feature operations and the support of CAN cycles. So generic feature operations are a really useful tool. We can kind of customize our own processes into a generic feature operation or generic motion operation, and we can put some conditional data inside of the menu to make changes or different processes available to us. In this case, we're going to look at the fact that with drilling operations, we can now support the actual CAN cycle output as opposed to just point-to-point output. So traditionally, that's what we would get. We would post out our code, whether you're looking at the CLS file or the NC code, you would see we're just doing point-to-point motions in a G1 fashion. So now here we'll go through and customize our dialog to go through and look for our different parameters that we want to include in our dialog. So all this cycle type data. We'll edit that into our dialog, and now we can make the settings just like we would in a hole making operation with our extend path settings, system parameters, as well as do we want to output machine cycles instead of the single motions. And quite quickly here we'll see that the difference in the CLS file or in the posted code is that we're actually outputting that cycle data now. So an enhancement in extending upon functionality that we already had, but definitely a good benefit. Moving on to hole making. We'll talk about a couple different topics here. First one being transfer moves. So we have a new transfer move for within and between features, as well as a new secondary transfer move. So when we're talking about within features, any given hole is a good example where you have multiple depths. In this case, we're doing some hole milling, and we are going to take a look at how do we transition from depth of cut to depth of cut. So we have the ability to specify that we now want to use our engage and retract settings. And this will allow us to have influence over the behaviors here. In the past, we would always just retract, we would just proceed to the next depth of the hole in a rapid motion. And there was no ability to change that. So now we can control how we get in and out of those cuts to the different levels, as well as the enable chip removal option, which will allow us to come all the way out of the hole to really clear that feature before cutting the next level. Just another way to avoid recutting chips. A rotary part is a good example of where to use the new secondary transfer type. And this will allow us to having a more efficient toolpath in these types of operations, where when we are doing kind of linear motions between features, we can have our primary transfer type applicable. But then when we get into doing the rotary portion of our transition from feature to feature, we can change and have a second transfer type to allow kind of the best of both worlds. We can be very efficient in that manner, essentially kind of creating groups of regions here, not just individual features as one static type. Sticking with hole making, we'll take a look at the threading bottom clearance setting that's now available. So hole making has seen a handful of updates, and what we're going to look at now is the fact that we can prescribe a set distance off the bottom of the hole that we want to maintain clearance for a tap or a thread mill. So in this example, we'll see we have a variety of different depths that we are going to tap this part to. A few versions back, we had the option of use predefined thread length that would force every hole, regardless of the hole feature, to tap to a specific depth. Now, when that option is turned off, we have the bottom clearance setting. So this allows us to make sure from the bottom of the hole that we maintain a certain clearance values. I'm sure we've all seen where we get a model for a 1-inch deep hole with a 1-inch deep thread, and that becomes very difficult to machine, and often is probably not really necessary. So this is a quick way to capture how much clearance do we need for a particular type of tap that we're using. Again, are we pulling those chips out of the hole? Are we pushing them down into the bottom of the hole and packing them? Well, regardless of what tooling we're using, we can feel comfortable that we're giving ourselves enough clearance. The same functionality works with a thread mill. So if we want to maintain some particular clearance value at the bottom of a hole when using thread mills, we can use the same exact setting and maintain that clearance value to the bottom of the hole. We certainly don't want to run the tip of our tool all the way down into the bottom of our feature. Okay, taking a look at material removal measurement per operation. This is just a little bit of information to the programmer. Perhaps you to use to kind of decide what cutting methods we may want to use. But what we'll see here is we have to edit our column configuration and add in the removed volume and material removal rate options to our column configuration, and make sure we save that configuration after we make any changes. And we will now see that under the toolpath option, we can calculate our removed volume. Again, to not hamper any performance here, we don't calculate this automatically, but we can provide this information by that simple right click and view it in the ONT. And again, this is a nice tool for a programmer to look, maybe I'm looking at some conventional roughing strategies. I'm looking at high speed strategies. Do I want to use adaptive milling versus high feed? I can get some feedback from the software to know what may be a more appropriate and efficient method. Single blank for toolpath animation. This is a great enhancement. It's really relatively simple in nature of what it does, but it's a huge benefit in my opinion. So I'm sure we've all ran into the scenario where we have to create and get a little creative with our geometry structure, and maybe we have different blanks for one reason or another in our program. And what that ultimately does in animation is cause the blank to change as we're animating. In this case, we'll see when we get to the last two operations that we have no change in our blank geometry, even though we truly do have different blanks selected. It's inheriting and using that initial blank. That's because the single blank operation was toggled on. Now that we've turned that off, we'll see as we simulate or animate the last two steps, we see that we did have some different blank geometry. So this new option, yeah, it's going to make a nice workflow for those types of scenarios where we do have to play around with our blank condition. So throughout this presentation, you may have noticed there's been times where I've used names for operations and tools that contained either spaces or special characters. And that's made possible by our next topic here, the NX naming rules. Traditionally, we've always had what is now called our system name, and there's been limitations that, yes, we cannot have spaces, no special characters, anything of that sort. But now we've added in a user-defined name, and that allows us to use all these special characters and spaces and have a little bit more flexibility with our naming conventions. So as we take a look at this, anytime we right-click in the white space of our operation navigator, we have the ability to choose what name preferences we want to have displayed to us. So under name display, we can choose that we only want to see the system name. That's going to be kind of the traditional behavior. We can see the system and the username if we want to see both, or the username only. You'll see under manufacturing and the user interface, we can choose our default settings in a persistent manner, as opposed to just the session settings that we can do on the fly. So now we'll see that as we change the name and add in some special characters and spaces, yeah, NX is quite all right with that. And we are showing both the system name and the username. So both can be displayed at this point in time. Of course, you can choose to show one or the other if you so choose. And if you choose to show the username, but one does not exist, maybe only the system name, that system name will be shown. So you're never going to see just a blank name at all. But we'll go through here and take a look at a few different scenarios of what some of the results may look like. In this case, yeah, adding some username to our tools. This is going to be true of any scenario here. And now here's an example. I'm choosing to show only the system name. I'm sorry, only the username. But you can see some of these tools, most of these tools didn't have usernames. They only have the system names. So if one is not available, it'll show the other in that scenario. By the same token, we can see our system name and username at the time of creation. Again, whether it's a tool, operation, method, geometry, same behavior all the way throughout. Now let's start talking about some enhancement for kind of along the lines of simulation and understanding of how your tool paths are going to really be applied to the machine tool. We have what's now called machine-powered programming. And this requires you to have a simulation kit, or at least a kinematically defined machine tool model. And when you have that kit that's been built with machine-powered programming, interactive inside of NX, we can click on our tool paths and show the actual machine position at any point in time. There's really kind of three criteria or three aspects that have been enhanced here. There's some new classification components for people that are developing simulation kits. We're changing the machine tool view to see the kind of machine context inside of your CAM setup file. And then kind of the core feature of showing the machine position inside of NX without going into simulation at all. So first talking about when we build a kit and looking at the machine tool builder application. We do have to have a MPP enabled kit, and that is done through the machine kit wizard, where we just simply check a box that it is enabling MPP functionality. And you can use this wizard to go ahead and build your simulation kit, the kinematic model, and the kinematic tree. And here we'll see we have some different classifications. Tool spindle, location pocket. There's a handful of other new classifications used. Again, typically those are kind of really reserved for those people that are building machine tool simulation kits. From a user standpoint, not so important. But the last aspect of MPP is going to be focused around the CAM programmer, the CAM user. So traditional behavior, if you're unaware, anytime you specify your part blank and fixture, all that information gets inherited into your machine tool kinematic tree. So now when we start looking at our operation navigator, in this case, we're going to be looking at the machine tool view. We can see that we won't see all the pockets and things that maybe we used to see inside of a traditional simulation kit environment if pockets were defined in the machine. Now everything kind of just goes into the spindle location itself, just simplifies the user interaction. On the display group of the ribbon bar, you'll see that there is now going to be a display tool in machine icon. When that object is turned off and we click on any given tool path with the select tool path option, the tool will be visible. When we toggle it on, we'll see that the machine is going to be positioned and moved very similar to what is happening in simulation. However, it's all being done directly in manufacturing. So this is really beneficial that we can see right away clearance issues, including things like spindle face, axis motions, all that kind of functionality. So pretty cool new functionality added in to the software. Again, we do have to have that MPP enabled kit, so that's something to talk to whoever develops your posts and sim kits for you about getting that done. All right, we're going to talk about a couple enhancements inside of some various operations. First, we're going to take a look at check geometry instead of multi-axis roughing. So, odds are you're familiar with check geometry and what that does inside of NX. But if you ever used multi-axis roughing, you may have noticed that that option was not available. We just didn't have the ability to specify check geometry. And here's a perfect example. Again, it's a very simple example, but in this case, we're going to go ahead and select the models that are kind of signifying or taking the place of clamps holding down this part. And when we generate the toolpath, this will now keep the clearance, whatever stock value you have, it'll keep that clearance away from your clamps or whatever check geometry you have. So there's a number of use cases here. One, of course, fixturing is likely the primary use case, but there's always other ways that other use cases that you may think of and be able to limit and kind of control what regions of your part are being machined just by using that check geometry option. And we'll see that, yes, we're able to specify the check geometry directly inside of the operation. We can inherit it from a geometry parent object, whatever method you're comfortable with using, that'll work just as you would expect from other operations. Now getting into our 3D adaptive operation, we have a couple enhancements here that we have a user-defined start point and the ability to define pre-drill points. So this is very useful. The start point just picks what part of the geometry, where do we want to start? Maybe we want to start closest to the machine operator so they can see what's going on as we're engaging. Or I think the bigger enhancement here is the pre-drill points. We have this functionality in other operations, and now it's been added to 3D adaptive roughing. As we all know, adaptive roughing, very efficient toolpath. But one thing that tools that are really kind of dedicated for this adaptive type operations generally have a lot of flutes, not a lot of chip clearance. So typically, especially in any kind of harder materials, you don't want to do like a helical interpolation to get into a feature. And this is where, again, titanium is probably a really good example. We'll just drill these holes, allow our tool to come in, and then start milling from that clearance geometry. So now we can do that inside of 3D adaptive roughing, that we can pick individual drill points to go through and specify where do we want to engage into our geometry, not with a helical interpolation, but just to feed down into the hole and then start with our regular cutting motions. So in this case, we can see the legacy behavior. We have not specified any pre-drill points, so we're just going to helical interpolate down into the feature. And now once we have specified, we're going to go ahead and wrap it down in this case, and then do a little helical interpolation and resume cutting in an adaptive strategy inside of the part geometry. So nice enhancement there for 3D adaptive. All right, finish walls with barrel tools. We now have a dedicated operation for using these tools. NX has long been able to utilize the various types of barrel tools, whether they're taper barrels, tangent barrels, what have you. But we had to use operations like streamline, variable surface contour operations to handle this. Well, now we have a dedicated operation, makes it incredibly easy to program these tools on a variety of part geometry. Again, this operation is intended for finishing wall geometry. A next enhancement will be a dedicated operation for doing floor geometry, kind of more of a lens approach. But here, looking at the finish barrel swarf operation, we pick our wall geometry that we want to cut, and we're going to specify our wall curves. In this example, we're going to morph between a top curve and a bottom curve, and you'll see how the tool path follows that morphing pattern. Or of course, we can pick either or, a top curve or a bottom curve. Your part geometry is largely going to dictate what type of method you're using there for the wall curves. So taking a look at this example, just finishing this corner wall geometry, we'll go through, pick the wall geometry, and now we have to specify some curves. In this case, the upper curves lend themselves very nicely to guide our toolpath. So we will go ahead and select that upper curve. It's important to note that if you transpose upper curve and lower curve, this kind of tells the software how to approach the part. So if you ever see that the tool is opposite the approach direction that you want, it's likely you have an error inside of your wall curve selection. So see, again, we're going to specify those curves, say okay, these are going to be our upper curves, and now we can generate our tool path, and very simply, we're going to get a nice tool path, smooth motions for repositioning from the engage to the retract side. Of course, we could use zig or zigzag type paths, or if we have geometry that lends itself to a spiral pattern, we could certainly use that method as well. Now, we don't always have geometry that has smooth upper curves or lower curves, and this is where we can use offset from guide. In this case, we just create a little cross-section, intersection curve to get a good guide curve created for us, and we're using that and offsetting both above and below that guide curve to cut the geometry. Jumping back to our example that we looked at previously, where we have one wall selected and an upper curve and a lower curve, kind of doing a morph between these two. As we see, we've selected the geometry. We can see the tool path and see how that tool does morph between those options. So again, I think this behavior is quite similar to maybe guiding curves, some of the options inside of the guiding curves operation, so likely not going to be entirely new to you. Quite a few different methods that we can use to control things. Of course, under our access and avoidance, we control the lead and lag values by specifying a preferred value, as well as a range, what is allowable for our tool and process here. And that's how we will control the lead or lag angle. And then the contact height, where are we actually cutting along the flute lengths? So in this case, we have the ability to pick between the minimum and maximum values here of our flute length. And we got to keep in mind that the minimum value must start at the point where the two radiuses converge. So the tangency point between the nose radius and the barrel radius. So this is kind of a percentage or a 0 to 1 value. So if I set my preferred to a tenth, that's going to put us up just 10% from the beginning of the tool, of the barrel radius. And 0.8 is going to be 80% of the flute length. So it's going to allow the tool to maintain contact anywhere in that range. It, of course, will try to maintain the preferred position, but it will, again, change that contact point based upon the geometry and the needs to maintain clearance for your tool and holder. Again, something to look forward to here. There's going to be some further enhancements, maybe some dynamic feed and speed settings based upon where that contact point truly is. Maybe we want to specify, a couple preferred points in our part. There's some discussions about a variety of things. The avoidance and axis smoothing option here, what do we want to do when we get into a sharp corner, when the tool really cannot fully form that feature? One, we can retract. So it's going to retract, re-engage into the part. Or we can choose the tilt and retract method. So it'll change the tool path. The tool path, honestly, I think it looks a bit funny by itself. But when you understand what NX is really doing here, it's trying to maintain contact as opposed to getting out of the cut, coming back into the cut, and continue on throughout the toolpath. So that's one that a lot of people are going to be happy about. And the last one here, mill turn workpiece. Just a simplification of our geometry whenever we are using a mill turn machine. Really combines the workpiece and the turning workpiece nodes into one object. So anytime you're on a mill turn machine, you need to have, traditionally, you need to have a workpiece for your milling geometry and a turning workpiece, which is derived from the workpiece spun outline. Well, now this is just all done inside of one geometry node. Makes your setup cleaner, easier. Not a huge change, but certainly a benefit nonetheless in mill turn environments. So we can see right away when we selected our geometry, spun outlines already created. We didn't have to go through and do any extra selections or things of that nature. We can also go through, and here we're showing physical workpiece. If you had multiple setups in your machine, you could dictate which setup you wanted this to belong to. All right, I think the last thing here is Cloud NC Cam Assist. This is not a Siemens product. This is a third-party product that is integrated into NX. I'm going to go ahead and open up a demo part. So Cam Assist, if you haven't seen anything about it or heard anything about it, is kind of an AI-based programming platform. But really what it is behind the scenes is Cloud NC got a bunch of people together and started setting some standards for how parts should be programmed. And so here we have a number of sample parts made available to us that I'm going to be using. And just to show you how easy it'll be to program a part. So let's see, in this case, we could do two setups. We could actually mill op1, op2 at the same time, program it at the same time automatically. But I might just, for the sake of this demonstration, I'm only going to work with this initial part file. We can see kind of our blank stock, our part. And so I want to show a couple things from Cloud NC. The first is going to be the softjaw designer. So oftentimes we have to create softjaws for our, I got to log into my account. We have to create softjaws for holding our parts in different places. So in this case, I'm going to go ahead and select my part. If I had blank jaws right now, I could pick those blank jaws. Otherwise, it's just going to give you some generic block, which is fine. I'll pick my spindle direction. It's going to be vertical. Opening, we'll say that the device is going to open along the x-axis direction. And let's go ahead and take a look at some of our settings. We can position some geometry in what Z height do we want to do. Maybe I'll make this a little bit smaller. Let's do 15. Interlock prevention. Make sure that, hey, we're not going to like get our part stuck in there, that we can't actually open it. We have corner relief sizes that we want to provide in any sharp corners. But we'll just go ahead and say OK, just to show a quick example of what's going on here. All right, so very quickly, software went through and created some soft jaws for me. And we can see in this case, I probably want to make my jaws a little bit shorter. Let's see here. If I take a measurement from the top of the jaw to the bottom of this face, 2.3 millimeters. Yeah, maybe I'll go through and let's get rid of those, and I'll create some new soft jaws real quick. Reselect my options. 15 before. Let's do 12 this time, and we'll say OK. And there we have geometry for our soft jaws for how we want to hold this part. Again, this would assume, for secondary operations that the bottom side was already cut. But just an example here. All right, so now what about actually programming this part? We go ahead and launch our Cloud NC Cam Assist tools. Through and utilize tools that are in our part session already. Maybe we know what tools we wanted to use. Maybe we have standard resident tools in our machines that we want to utilize. Or perhaps we just want to use the out-of-the-box libraries that Cloud NC provides to us. And if that's the case, we could certainly do so. But in our case, we want to start just kind of working through this dialog. We're going to look at setup. We're going to do just a straight 3-axis operation. It's looking at our part workpiece setup here. Maybe I'll make the screen a little bit larger. Machine full part. Yep, we want to machine everything. I don't want to pick individual faces, anything along those lines. Excuse me. Machine, it inherits my machine data from the setup here. If I had a kit load it, it would know what that machine is, what the max, min, spindle, power, all that kind of stuff is available to me. Tools, I can pick different libraries, so on and so forth. Tool usage, I can get in there and specify different tools are available for different features. But in our case here, I'm going to go ahead and toggle on what types of features do I want to do in this operation. So I want to do face milling. I want to do my roughing, detailed roughing, arrest milling. Let's come in and do hole operations, deburring, all that kind of stuff. Folder names. Do I want to change the names for how things are going to be grouped in my operation navigator? Not important for what we're doing right now. I'm going to just say OK. So this is going to go up to the cloud. It's taking kind of the geometry of the part. It's going to identify and map what operations to use, send them back to NX and generate them, and then we'll have native NX operations in a complete program or a near complete program for our part. And we're totally able to edit those operations just as if they were any other NX operation that we created natively. Change tools, change settings for our personal preference, things like that. But really a nice tool and a nice process for a couple things. One, not having enough employees, enough manpower to go through and program your parts. Maybe for newer employees, a great way to get the bulk of the program created, and then yes, we just want to go in and tweak for maybe company standards of how we like to finish things, or various order of operations. But again, quite a robust tool. It's going to get the bulk of your program done and allow you to go through and fine tune it on your own, and let the person that's sitting at the computer programming just focus on the details and kind of the fine finishes, as opposed to having to worry about all more of the non-value add content here. So it looks like we're just about done with this part program. Do the last couple holes here. Deburring. Take a look at our program. So we went through, it started with a roughing operation. I didn't assign the soft jaws as geometry here because this would really be operation 1. So you can see doing an adaptive operation, then coming in, starting to do some floor wall milling, targeting specific areas, different geometry here. It identified that it needed to use some different tools between the geometry here, maybe for reach in this case, a variety of kind of finished wall operations going around targeting the different geometry, grouping these all together. Hole making, chamfers, deburring, all this sorts of things. And again, we can go in and change and influence any of these operations. So in this case, geometry, I'm picking these faces. Maybe I do want to finish, all of these regions at the same time. And I don't want to do a tool change here. Maybe I just want to choose, I believe it was the 12mm tool. Millimeter bull nose, and chose the right 13611. Let's change that. There, we can change our program quite easily. The last thing I'll kind of point out is this Cloud NC Cutting Parameters Explorer. When I go ahead and launch this tool, it's getting all the information for the operations from NX right now. And we can go through and choose individual operations now. And we get a report of the depth of cut, width of cut that's being called out in the operation, spindle speed being used, feed rate, and I can grab these parameters and change them. Maybe I want to go to 35. Sliders, and we can see that we can change our productivity values, different things of that nature. Only the ones with the blocks there. Let's do this. Let's go 15. So 15 millimeter depth of cut. You can always reset things. So pretty interesting. And the unique thing is you can save the operation. It's going to send all that data back to the toolpath now. Again, I do have to regenerate my toolpaths. But a nice way to make some bulk edits to your part file. Maybe you find the data that comes from the software too aggressive or not aggressive enough. And so a quick way for you to change things up there. All right. Well, that was the last little bit I wanted to show you there. With that, I thank you for attending this session of What's New in NX, and I hope you enjoy your day with us here at NX University. Thank you.
In this presentation, we're going to be taking a look at hidden gems in NX CAD. Taking a look at our agenda for this presentation, we'll be looking at suppress by expression, as well as NX part attributes and attribute templates. For the first discussion, we'll be taking a look at suppress by expression. We'll take a look at what is suppress by expression inside of NX, benefits of suppress by expression, use cases for it inside your designs. First off, what is suppress by expression? Suppress by expression option in NX is going to allow you to automate feature control, enhance parametric flexibility, improve performance, reduce errors, and simplify complex models for adaptable designs. Essentially, the workflow for suppress by expression inside your designs is going to be 1. Define an expression. Open the suppress by expression feature dialog. Suppress by expression can be found under Menu, Edit, Feature, and you'll see suppress by expression on the flyout menu. Selecting that option will open up the suppress by expression dialog. Next, we're going to apply the suppress by expression condition to features. We need to select the features for suppression or activation based on different conditions here. Third, we'll modify the expression to suppress or unsuppress the features inside the design. A new expression is going to be applied to the designated features that we've chosen. That's going to control the suppression by expression state inside the design. And finally, we can set conditions and define rules that are going to trigger the suppression, such as if length is greater than 50 millimeters, suppress feature A. What are some benefits of the suppress by expression inside your designs? Suppress by expression is going to offer many great benefits for controlling a part's design configurations. Benefits of using suppress by expression inside your designs include automated control. This is going to allow automatic suppression or unsuppression of features based on logical conditions or expressions, reducing manual inputs. For example, P181 equals 1, which equals unsuppressed. So essentially, when the expression P181 is set to the value of 1, you are going to be turning the features on inside the design. If you set that P181 expression to 0, you are suppressing or indicating that this feature is to be suppressed and suppressing those features inside the design, turning those off. It also allows for parametric design flexibility. This is going to enable you to suppress features when certain conditions are met. For example, if you have part dimensions or different configurations that change, that could potentially turn something off in the design or turn something on. This is going to enhance the flexibility of parametric models. Also, optimize design process. It is going to simplify complex models by suppressing unnecessary features during certain design phases, improving model clarity and efficiency. In the example image off to the right, we have a pocket that's inside of this particular design. We have created a suppress by expression related to that particular feature or feature set. When somebody sets a particular suppression expression to a value of 0, you are suppressing those features inside the design or turning those off. If you go in and change the suppression expression to 1, you are going to tell the software to bring those or turn those features back on inside the design. So let's take a look at suppression by expression in a demonstration. All right, in this demonstration, we're going to be taking a look at the suppress by expression operation inside of NX. Here you can see I have a part that's opened up, and it's just a simple part. I have a pocket inside this circular type body. Pocket at the center of the body here. You can see over in the feature in the part navigator tree. If we navigate down, we can see we have feature group pocket 1. There's also a second pocket inside of this design. Currently it is suppressed, and that is contained in feature group 21 here, pocket 2. If you have a design scenario like this where you might have alternative representations for that particular design, in this case we have a pocket here and a pocket here, one of these is currently suppressed inside the design. This one is currently active, that's what we're seeing inside the design, and pocket 2 is currently suppressed inside this design. Inside each of these feature groups, if I expand those by selecting on the plus node here, you'll see we have a series of different features in here that would make up the pocket. We have a sketch, an extrude, an edge blend, I did a delete face operation, subtract, which subtracts the pocket out of here as well. All right, so that's feature group pocket 1, and feature group pocket 2 has a similar set of features, and there's additional features in here that give some additional features on that pocket. If you have a scenario like this now, how do you control if I can show one pocket or one particular design element on my part and suppress another in my design? You're going to start by creating what's called a suppress by expression condition inside the design. In order to do that, you'll have to access the suppress by expression operation. Under Menu, Edit, Feature, you'll see suppress by expression on this flyout menu here. So there's the suppress by expression. Again, Menu, Edit, Feature, suppress by expression. We're going to activate that or open up the dialog here. And once we have that opened up, you can see in the suppress by expression dialog, first thing we need to do is decide if we want to create a shared expression or an expression for each. Essentially, what you're doing here is you're defining, if I have, like I demonstrated earlier in the part navigator, a pocket or a group of features that I want to suppress with one single expression, I can do a shared expression here. That way I can apply that single suppress by expression condition on all of those features in that pocket 1 group. If you wanted to individually control those with their own individual suppress by expression value, each of those features being a 1 if you want to show it, or a 0 to turn those off, you can do that for each feature if you want to. But to be more efficient in the design, in this particular case, I have a group of features inside of a feature group in my part navigator, pocket 1 in this case, and I'm going to create a shared expression. So create shared for my expression option. Next thing you need to do is designate the features that you want the shared suppress by expression to apply to. So if I go back over to the feature tree, you can easily expand that, hit the plus node next to the feature group, and I can click on the feature group here. Just by selecting on the feature group with add dependent features turned on here and the related features section, check the box, it automatically selected all of the features that were inside that feature group for me in one pick. So I picked on the feature group and it selected all the features that are inside of that feature group. All you have to do now is go ahead and select OK, and it's going to create the suppress by expression for that feature group and all the features inside that feature group. It creates a single expression here. So I'll select OK. Once you activate the suppress by expression state on a feature, you'll note in the part navigator you have these symbols that show up, the equal symbols, inside of all the checkboxes here. Where before you had the show hide indicator next to the features, we now have an equal symbol, a green equal symbol inside those boxes. The green equal symbol, whenever you see this, this indicates that these are being controlled with a suppress by expression condition. Currently, they are active inside the part file here, therefore they have the green equal symbol. If we further investigate and click on the feature group here, and if you expand the details panel down below in the bottom of the part navigator, click on the details panel, you'll note that the equals suppression parameter here has a value of 1. A value of 1 indicates that this is unsuppressed or visible on the design inside my design. If I want to go ahead and turn that off, that feature off, or that set of features off with this one expression, I can change that value from 1 to 0. Once I do that, you can see all of those features, the feature group, and all the features inside the feature group have been turned off inside the design. They have been suppressed. And so this is the benefit of the suppress by expression capability in the software. We can easily create these suppress by expression conditions on a single feature or a group of features and control all of those with a single suppression parameter here and turn that feature off or set of features off inside the design. Now let's imagine that we have this feature group for Pocket 2 and we want to go ahead and be able to turn that one on. We can expand that. I'm going to go down here. You can see the current feature in the current feature column right now. You can see currently the Pocket 2 is the current feature inside the design, but it's currently suppressed inside this design. Now I use my suppress by expression up here and I've suppressed these with a parameter suppression value of 0. So these have been suppressed in the design. I'm going to go down to this feature group for my pocket 2. I'm going to right click on that, and I'm going to choose to unsuppress that right now and bring that back into the design. So now you can see that additional pocket has showed up. We have a boss with a threaded hole in the center of the boss. Now, if I want to go ahead and turn on a suppress by expression condition for this one, so I can easily toggle back and forth later on with an attribute, I can go back up here to Menu, Edit, Feature, and then go into the suppress by expression option. Open that up, go through the same motions, create an expression, or use the expression option, and create a shared expression. I'll select on the top level group. Selects all the features inside that group for me because I have add dependent features checked here. I will select OK next. And now we've created the suppress by expression condition for feature group pocket 2. Now this is setting up the groundwork for when we talk about attributes. The ability to control and have these toggle back and forth based on an attribute change inside the design is what we'll talk about in a little bit. So right now we have 2 suppress by expression conditions here inside the part. This one is currently turned off with a value of 0. And feature group pocket 2 has been turned on with a value of 1. So this is currently unsuppressed and visible on the part. These are also going to show up. You can see it creates expressions. If I go into Tools, Expressions, my expression dialog here, you'll note that we do have the expressions that will show up in here. You'll see we have P182 right here and P181. These are the suppress by expression parameters that we created with those 2 operations. You can rename those, call those whatever you want to call those. If you double click inside that field right there, and I can call this one, I believe this was pocket 1. So I'll call that pocket 1 suppression state. And you want to verify that, you can always go back over to the feature tree and you can click on the pocket 1 here. Here's a little tip for you. If you pick on a feature with the expression navigator open here, expression dialog I should say, pick on a feature inside the part or inside the part navigator, and it's going to show you the expressions related to that selected feature here. So I chose the feature group 16 feature, pocket 1 is the name of that. I can see the expression related to that is this one here that I've named pocket 1 suppression state. If I want to change the name for this suppress by expression parameter, I can click on feature group 21, pocket 2. I can see it's currently P182, which doesn't communicate to anybody very clearly what that's doing, so I can change the name. Just double click on that, double left mouse button click on the parameter value here, and I can call this pocket 2 suppression state. Now we have a clear description of what this expression is doing or controlling. So in this case, if I want to suppress pocket 2, I can change the formula here to 0, hit the enter key, and then remember to hit apply here to accept the change. Now once I've done that, you can see the pocket has been suppressed in the design. Again, if you click on the feature in the feature tree here, you can see down in the details panel there's my pocket 1 suppression state equals 0. I can double click in here and I can set this to 1, hit the enter key, and bring back the first pocket in the design. So this is going to allow me to control the appearance of this geometry, these features, turn those on and off inside the parts. So that is a demonstration of creating the suppression by expression state on your features inside the design. And then we went ahead into the expression dialog here and we renamed those to something that's more familiar, easier to understand what that's doing inside the design here. If I go back to all expressions, now if I see a long list of expression names here, I have some descriptive names, and I understand that this pocket 1 suppression state, this is controlling the suppression state with a 1 or a 0 here to turn that feature or set of features on or off inside the design. Now, if you need to delete a suppress by expression condition inside your design, I'm going to go ahead and cancel out of the expression dialog here or select OK to close that. If you did want to get rid of a suppression by expression condition on your parts here or your features inside that design, you need to go back into the suppress by expression dialog box. Again, that's under Menu, Edit, Feature, and then suppress by expression. Open that back up. Now, instead of creating a suppress by expression condition inside my design, I want to remove a condition. So on the expression options, you're going to hit the drop down and you're going to choose one of the two delete options here. I can delete for each or delete a shared expression condition. In this case, if I want to delete a shared expression condition, I can click on delete shared, and then I can come over and pick the feature or feature group that contains the features that are sharing the suppression by expression condition on them. Select on that, and then I can select OK to delete those. And now it goes right back to showing the show hide icon back to the left of those features inside the feature tree. We've now removed or deleted the suppress by expression condition on those features. So that is suppressed by expression inside of NX. Next, we're going to take a look at NX part attributes and attribute templates. So we'll take a look at what are NX part attributes, benefits of using attributes, attribute templates inside your design. First item we'll discuss here is what are NX part attributes. NX part attributes are going to streamline the design and documentation by automating the inclusion of critical part information, enhancing your searchability, and ensuring consistency across assemblies, drawings, and PLM systems. In 3D modeling and assemblies, attributes are applied directly to parts or assemblies, providing essential information such as material, weight, or configuration controls. Inside drawings and title blocks, attributes automatically populate details like part numbers, material specifications, and revisions in the title block and notes inside drawing views. In bill of materials, part attributes are included in BOMs to provide additional details like vendor information, material type, or specific property. In product lifecycle management, PLM integration, when integrated with PLM systems like Teamcenter, attributes synchronize to manage revisions, metadata, and product data across the lifecycle. To access the NX part attributes, you can go into File, Properties. On the Display Part Properties dialog, you'll see there's an Attributes tab. You can go ahead and click on that. Once you select the Part Attributes tab, you'll see down below in the panel the part attributes will be presented. Any part attributes that have been created inside of this part will be displayed inside the Part Attributes panel. Taking a look at benefits of part attributes, using NX part attributes inside of Siemens NX is going to provide several advantages that help streamline design, improve collaboration, and enhance documentation and organization. So here are some key benefits with part attributes. One, standardization of information. This allows for part attributes that are going to allow you to attach consistent and standardized information such as material type, weight, designer, revision number, etc. to a part or an assembly. This is going to help to ensure that all team members are working with correct data. Additionally, automation inside of drawings. When attributes are properly set up, they can automatically appear in drawing views, title blocks, and parts lists. This eliminates the need for manually typing in critical information like part number, revision, or material properties. In the example images off to the right, you can see in the Displayed Part Properties dialog on the Attributes tab, Part Attributes Panel section, we have a couple of attributes that have been created inside this part. Under the general category, somebody's created a part underscore category and the value is set to base. They've also applied a material to this particular part. When a user applies a material to a part, that applies mass properties to that part. In this case, our materials category includes mass property density, mass property mass, and material as highlighted in the image. On the image below, you'll see on our drawing sheet, we have a general note that calls out or references the attributes above. The material attribute is aluminum 6061. The density, you can see, is 0.098, as well as the weight is 15.76 pounds. The part category is base. So part attributes in this particular case, somebody's applied those inside the part file, and those are being referenced on a drawing sheet. In this case, inside the general notes. If somebody updates those attributes inside the part file, those will update automatically in that general note on the drawing. Continued benefits of part attributes, automation and customization. NX does allow for the automation of processes through attributes. For example, attributes can drive custom NX rules or methods such as controlling part configurations or defining parameter-based modeling approaches. Also allows for interoperability with PLM systems. When integrated with product lifecycle management, such as Team Center, attributes can be automatically synchronized, improving collaboration and traceability throughout the product lifecycle. Over on the right, we have an example of a particular part that has a design configuration attribute that somebody built called pocket_type. The value is currently set to 1, but if a user were to change that value from 1 to a 2, you can change the product configuration. If that value is set to 1, and the image on the bottom right, you can see configuration 1 is going to be a single pocket in the design. Configuration 2, to the left of that, you can see that is a pocket that has a boss with a threaded hole in it. So somebody can easily go in and modify the pocket_type attribute and set that from 1 to 2 or 2 back to 1, and they can easily change the configuration of this design. Part attributes continued. Out-of-date indicators inside the part navigator. When you do begin to reference these different attributes on drawing sheets in this particular example, the part navigator next to the drawing and the sheet indicators will have an out-of-date symbol. The out-of-date symbol will be a clock with an A symbol or A icon over the clock. If you want to resolve the out-of-date attribute references, the user can select MB1 or click on the icon and update the drawing sheet and objects. In this particular case, something has changed in the part file with those attributes for the material and the part category, so the user has to go into the drawing, they'll see the out-of-date symbols, and all they have to do is click on those symbols to update the drawing and pull in the updated attribute information. The general note will update, and the density and weight in this particular example will be updated accordingly. The next thing we'll look at here is attribute templates. Attribute templates in NX are going to ensure consistency, save time, reduce errors, automate property assignment, improve collaboration, and enhance organizations by applying standardized reusable attribute sets across designs. We can create custom attribute templates that can be reused, allowing for time savings, error reduction, standardization inside of our parts, as well as customizable. Custom attributes can be used to drive part configurations as well. Using attribute templates in combination with suppression by expression in Siemens NX provides a powerful way to control part configurations automatically. We can define an attribute template, create the suppress by expression condition on features inside the model, and then we can link the attribute to the suppress by expression using conditional formulas. In the same example we talked about previously, we can build a suppress by expression condition inside of a design where that suppress by expression is referencing an attribute in this particular case. Over on the right, we have our expression dialog that you can see opened up. We have two variables, P181 and P183, these two expressions that are suppressed by expression parameter values. These are going to be controlled by conditional formulas. You can see P181 states if pocket_type attribute equals 1, then 1 or unsuppress, else 0. Also, P183 is also an if statement. If pocket type equals 2, then 1, which means to unsuppress the feature inside the part, else 0. That's going to suppress it in the part. If somebody changes that pocket_type attribute in the design, it's going to update and affect these formulas. So let's take a look at attributes and attribute templates inside of our designs in this next demonstration. In this demonstration, we're going to take a look at attributes inside of your part files, how to create attributes inside of your part files, and their use cases as well. So let's start out by looking at this particular part that we have open here. You can see it's very similar to the part that you saw in the previous demonstration. And with this particular part, we do have over in the part navigator a couple of different feature groups. I'm going to expand the column here so you can see we have feature group 16 called Pocket 1, renamed to Pocket 1 there. And also we have feature group 22, Pocket 2. Inside of each of those feature groups, we have a series of different features nested into those groups, respectively. As you can see down below with Pocket 2, similar situation here. Now you'll also note that we do have the equal symbols next to each one of these features. These equal symbols, if you recall, these represent a suppress by expression condition that's been applied to these features and this particular feature group here, as well as feature group 22, Pocket 2. So all those have the same equal symbols next to them. So currently inside this design, we have two pockets, two different configuration potentials here for this design. This is the pocket for pocket 1. Pocket 2 is down below here, and that's currently suppressed inside my design, while pocket 1 is active, indicated by the green equal symbols here next to each one of those features. Now, if you want to switch these configurations, you could manually go in, or you can select on the actual feature group here. Down below, you'll see there's a suppression parameter here with the value of 1. And then you can type in 1 or 0 here, or in this case, you can see we do have a formula that somebody had built inside this part file here. We'll talk about that in a little bit. We'll explain what's going on with that formula. But the manual method for turning these on and off, these two different configurations, would be changing the suppression parameter from a value of 1 to 0 to suppress pocket 1. Then I would come down to pocket 2. I would select the suppression parameter here, and I would set that value to 1 to turn that on inside the design. All right, so there's a lot of manual work going on there to be able to change the configuration from one pocket type to another pocket type here. There's a much easier way to accomplish this and much more intuitive method to build your parts to change the configurations more quickly and more efficiently here. In order to do that, we can use something called an attribute. Now, I'm going to show you where attributes are created inside of parts, where those exist, and how you can interrogate a part file to see what attributes exist for that particular part file. So let's take a look at that first. Going back up to File, go down to the Properties option here. So again, File, go down into the Properties options here. I'll click on that. And inside of our Properties or Display Part Properties dialog box here, we have a series of tabs at the top here. And the tab we're interested in currently is the Attributes tab. So clicking on the Attributes tab, you can see down below, we have a couple different ways we can interact with this panel of information. We have a table that's currently being displayed. The interaction method is currently set to traditional. It's been like this in the software for many years, but there's also another way you can view this called bulk edit. It's entirely up to the user how you want to present or view your attributes. If I expand this, you can see the bulk edit mode is going to show you key categories at the tops of the table here. And you can expand these just like you would an Excel spreadsheet. Open that up so you can read more information there if you need to do that. And so you can represent or read your part attributes in this kind of a table format. My preference is the traditional, so I'm going to go ahead and switch back over to traditional. This is the way that it's been in the software for many years. Traditional layout, you have a table set up here with the categories nested, as you can see here. So no category, any of these particular attributes that have no category assigned to them or they don't live inside of a certain category here, those are going to be in the no category section. Down below, we have a database component instance group, a design configuration group or category, a general category, mass properties configuration context category, and materials category down below here. So these are my category names. Nested inside of each category, you have the particular attributes that somebody has defined or Siemens has defined inside of the part file for the user based on what someone's doing inside the part. There is potential for attributes to be assigned automatically in the background. So you can create user-created attributes, or you can have what are called system-generated attributes based on what's being created inside this particular part. An example of a system-generated attribute would be under the mass properties or the materials categories here. The system will generate these particular types of categories as well as the attributes inside those categories depending on if somebody's applied a material to the physical geometry. In this case, we have a materials here. Material that's currently applied is aluminum 6061. So essentially somebody went into the materials library and they applied a physical material to the geometry of this design here, this part. And so that material, its properties are automatically inherited from the material into the part attributes here. It goes into the materials category, and you can see the material missing assignments, and so on and so forth here. So a variety of different options here, whether they're user-generated attributes or system-generated attributes. This is where the attributes will be displayed for the particular part file here. If you need to build your own attributes here, you can certainly do that. We do have a couple of attributes in here that a user has created. I can see I have a design configuration attribute group here. We also have another category called general. And so inside the design configuration category here, somebody's created a attribute that's called pocket underscore type with a value of 1 here. You can see the type is an integer. There's a save diskette next to this. You'll see if I expand this column here, it does say read only. And this is very important because when you create user-defined attributes, these can be written over and changed inside this part file. Down below, you'll see we have mass properties and materials categories with attributes respectively in there. And you can see we have a lock indicator. This attribute is owned by another object, or this is a system-generated attribute. These system-generated attributes cannot be edited inside of the attribute dialog here. This is not possible. You'll see they're locked. If I try and click on the material attribute over in the next category down, this section here, you'll see we have a lot of category sections that are grayed out. And that's because these are system-generated attributes. These are populated from some other area of the software that help to generate the information for this particular attribute. These are not going to be editable inside of this tool here. All right, so how do we create attributes inside of the software here? I can do that very easily by creating my own attribute by clicking on the new attribute button here. If I click on the piece of paper with the plus symbol here, I'll click on that and create a brand new attribute. And when you're building attributes, you have to go ahead and decide the category you want that attribute to be a part of. If you hit the drop-down menu here, you can see all the categories that are currently existing inside this particular part. And we can pick the category we want this to sit in. So if I choose general, I can come in for my data type now. I can give that a title if I want to. So what do I want to call this particular attribute? I can call this vendor name maybe. So who's going to produce this part for me? And you do want to separate the spaces with an underscore. You don't want to leave an empty space there. So you want to do an underscore, and I'll do vendor underscore name here for my attribute name. Now for the data type, this is a string of text. As you can see on the dropdown, you have a variety of different types of data you can create here. But this is a string of text for my vendor name, and I can type in a name there. So I'll type in Swoosh as the vendor that's going to create this particular part. When you're ready to create an attribute, all you have to do is hit Add New Attribute, click on the checkbox here, and you can see in the general category, we have a vendor underscore name attribute here. And I'm just going to double check here and type in the name here. I forgot to hit enter on that. So I'm going to go click into this. I'm going to type in Swoosh here, hit the enter key. And now you can see Swoosh is showing up in the value column there. If you do type in a value here, make sure you hit the enter key to have that accept that value. And you can see now the vendor underscore name is Swoosh. All right. So now that we've established where are attributes inside of a part file, where do we find these? How do we create them? Understanding the difference between a user-generated attribute and a system-generated attribute. Next thing we're going to look at is going back to our original discussion of how do I control inside this design different configurations for this design. We're using a combination of suppressed by expression. We have a feature or a group of features here that have a suppressed by expression status on them or condition on them. And now I'm going to show you how you can use an attribute, create a special type of attribute that can toggle something or change that attribute value, and in conjunction with a formula, turn the configuration on to show pocket 1, or turn pocket 1 off and turn pocket 2 on. So the next step we're going to look at here is creating a custom attribute template. If we go back into File, go down into Properties, you'll note that we have our design configuration category here. And you can see we have our pocket underscore type that somebody created. All right, so you can go in here inside of the pocket type underscore type 1, we can go into that configuration or design configuration attribute, pocket underscore type. It's currently got a value of 1. Now let's take a look at what happens here on the value dropdown. So go into 1 here, hit the dropdown for the value dropdown, and we're going to choose 2 instead. Once you change the attribute value here, you have to hit the green check mark to accept the change. And next you have to hit apply here to accept the change to that attribute and have that propagate out into the rest of the part here. So I'm going to go ahead and apply here. And you'll note in the graphics display, you saw a quick flash over here. The geometry has changed. We now have our second pocket configuration being displayed inside the design. So we have a pocket here, we have a boss, and we have a threaded hole in the center of the boss. So this is the benefit or the power of using attributes to control different design configurations here inside your designs, turning things on and off very quickly. It's intuitive, it's efficient. It helps somebody understand, okay, I have a part here, and I can go into the attributes and change a few attributes, and I can change this part completely by turning things on and off with these different attributes. So how do I create a specific type of attribute like you just saw with the design configuration pocket underscore type attribute? And how did that control the suppression state on one pocket type and unsuppress a second pocket type? So let's take a look at that now that we understand that we can use these attributes to control the design configuration. Let's take a look at what the process looks like here. If you go up to Tools and Expressions, you'll note inside of my expressions dialog here, we have some expressions that show up at the bottom called pocket1 underscore suppression underscore state. There's a formula here, and then pocket2 underscore suppression underscore state. And we also have a second formula here. We have two formulas that are being used, and inside of those formulas, you are going to see our attribute name here, pocket underscore type in the second formula here. We have an if-then statement that's controlling the pocket being turned on and off there inside this design based on the condition of this attribute's value. If I go into my attributes and I change pocket underscore type to 1 on that drop-down list, it's going to go ahead and set this pocket1 underscore suppression state to a value of 1. Our if statement states if pocket underscore type equals 1, then this value here should be 1. That means that this is going to be unsuppressed, and you can see if pocket1 underscore suppression state pocket underscore type equals 0, then the else here states that if this value here is 0, then this is to be suppressed. So we've created a formula here that's going to unsuppress and suppress something based on a condition with the attribute and the value of that attribute. Same situation down below with our pocket2 underscore suppression underscore state. You can see pocket type equals 2. So if pocket type, that attribute changes to a value of 2, then 1. Then this reads out as a value of 1, unsuppressing that particular feature. And if this pocket underscore type equals something other than 2, then it's going to be 0 here for the value, suppressing those features. All right, so that's how this is working. And I'm going to go ahead and show you how we can create the pocket underscore type expression, or attribute, I should say, inside of the part. So I'm going to go ahead and cancel out of there. We're going to go back up into another operation here under File, Utilities, and there's something called attribute templates. Attribute templates, these are going to be where you build custom attributes that have these different types of conditions on them. So I'm going to go into my attribute templates, open up that dialog box. Inside of the attribute templates, you can see we have a couple of attributes that somebody's defined inside this particular part file here. So you can see the templates, we have part file, and we have catalog. If I click on catalog, you might see a catalog of different attributes down below. I don't have a catalog right now, so I'm going to click on part file, and we're looking inside of this part file right now. What attributes are defined inside of this part file here, these template attributes. As you can see, we have a design configuration category here, and we also have pocket underscore type. This is the attribute that you saw inside of the part attributes, as well as part of those formulas that we just looked at a moment ago. How do you build one of these particular types of attributes? If you want to build a brand new attribute here, we can come down and we can go ahead and create or copy selected template if you want to do that. If I want to create a copy of this one, I can click on the copy template. If I want to delete that, I can click on delete selected template. I don't want to do that. If I try to hit the X here and delete that, the software is not going to let me do that anyways, because it cannot delete template pocket underscore type because it's being used. So you don't have to worry about the accidental deletion of these attributes, these template attributes, if they're being used somewhere inside this part. You do not have to worry about that. The software is not going to allow that. So I'll select OK here. If I want to create a new attribute, I can go back up, click on the part file option here, and I can start to build a new attribute here. So the category, you can choose an existing category. So if we had something else, maybe a tab that gets added to the side of the part here, I can make that as part of the design configuration category, and I can say tab. So I'll type in tab here, maybe tab underscore type. And so I have a different type of tab that might show up on the part, maybe in a different location on this part, based on this attribute's change. That's what we're setting up here. Very similar to the pocket type that we established earlier here. For the data type, this is going to be an integer type of data. So it's going to be a 1 or a 0 here, or a value per se. And now we're going to set this constraint type. You can do upper, lower, upper and lower limits, or a list. So if we look at it currently set to none, you can put in a default value here. You can let somebody type in a value for whatever that tab underscore type is going to be. But for my case, if I'm going to have multiple different tab types, I might want to change this to a constraint type and set that to a list. All right, so maybe I have 3 different tab configurations I'm going to be designing on this part, and I want to be able to turn those on and off with different conditions inside this design. So I can go ahead and start to populate my value list and start to type in 1. When you're typing it or you're building a list, all you have to do is type the number, hit your enter key to go to the next line, and type in the next number. Enter key, and 3. So we're going to have 3 different tab configurations in this particular design. And now I'll be able to choose those in my attributes, my part attributes. I can hit the drop-down list and choose which configuration of tab that I want to show up on the design here. All right. Enforce constraints, what this is going to do is it's going to tell the software that a user can only pick 1, 2, and 3 on the drop-down list. They cannot enter their own value. So if I only want to allow people to choose between 1, 2, and 3 on that drop-down list without typing their own value in on the list, I can enforce the constraints there. These are my constraints. We have a list to allow someone to choose a number from that list. I want to enforce the constraint on that. All right, you can also establish a default value. So for default value, I want tab number 1 to be my default tab in this configuration or this particular design. I'll type in 1 here. It's going to use 1 from that list, and that's going to be the default attribute value when somebody opens up this part, or if they were to create another part using this part template. You can type in a note here, and I can say this. So we'll type in a note, general note here. All right, so I just put a descriptive note there. You can type whatever you want, whatever you think is going to help another user when they open up this part file and they begin to work with the part file and they look at this attribute. So this controls which tab is used inside the design. You can lock the attribute when the part is saved. What this essentially does is it locks this attribute, and you can no longer edit this attribute template. If this is something you want to be permanent inside this design, be careful with locking an attribute, because once you lock an attribute, you cannot delete that attribute. You can do that with a secondary program using some coding outside of this program, but as far as inside of NX, if you lock an attribute, you cannot unlock that attribute after this part has been saved. So be careful with that option. I'm not going to lock this right now, but if it's something you want to lock in on your template here so nobody can delete that attribute out of the part file, or they are unable to edit that going forward once you save a template part. I can allow an attribute to be copied here with this checkbox. I'll go ahead and leave that check there if I want to allow someone to copy this one and reuse it with some other data. Also, you can allow multiple values here, and you can limit access to parts and objects or different areas of the software. So parts only, objects only, and you can do a custom option here. This attribute template will be accessible by the combination of object types below. So a couple of options to choose from there. Once you're ready to save this attribute, you can go ahead and select apply. And now you can see in my design configuration, I have a tab type and a pocket type here. So these attributes will now be inside of this part. If I select cancel here to exit the attribute templates dialog, and then we go back up to file, properties, you'll note we now have a tab type attribute here. Currently it's got a value of no value here, but it does default to 1. If I hit the check mark, you can see the item, the value has changed to 1 for the tab type here. All right, so that's how you build a custom attribute template that's going to show up in your attributes inside the display part properties here. All right, once you do that, now you can use that in formulas to control the tabs. As you further work on this design, you can build some tabs here, a couple different configurations for those different tab types, and you can use the same process with creating an expression. You can see pocket 1 underscore suppression state, pocket type equals 1 there. You would go through the same motions here to build the same scenario with the tabs. All right, so that's one area where you can use attributes in your designs. Another area where we can use attributes is we can use those to populate drawings, information on a drawing. If I go over to another part that I have opened up here, I have an attributes 1, drawing 1 part. I'll click on that. I'm going to open up the drawing here. You can see currently our part navigator is displaying some out-of-date clocks here. That means if I click on the clock, it's going to update the drawing. And you can see we have our pocket configuration with the hole, the threaded hole on the design there. Now, the one thing we want to focus on here, though, is there is a general note in the bottom left corner. We can see there's a material, a density, a weight, and a part category being displayed, the information related to that. Currently, our density and our weight, there's nothing being displayed here. Now, the reason being is because over in the other part file, you want to make sure you update the attributes. You want to make sure you update the mass properties for that part and pull in the density and the weight from that part. If we look at this particular note, I'm going to double click on that, double left mouse button click and open that up. We can see we have material, density, weight, and part category. Over to the right of the general words, this is just general text right here, the word material with the colon here. Over to the right of that, you can see aluminum _ 6061 has a gray background. This to me as a user tells me that this is being derived, this information is being populated or derived from somewhere else. If you place your cursor over that, you'll see a pop-up that says object attribute NX _ material. If we look at this particular drawing and we go to the assembly navigator, I can see that this is a master model setup here. Master model setup being I have an attributes1 drawing file, and then inside that file I have the part file attributes _1 part. So this is coming from another part file here. I'm referencing the aluminum material that's been applied to that part, the attribute, pulling that into my general note, and now that's going to automatically update inside the general note. If somebody were to go in and change the aluminum material to a stainless steel or a different type of aluminum, that will automatically update on my drawing sheet here. On the density category, if I put my cursor over to the right of the density category past the colon, you can see there is a little gray bar right there. And if I put my cursor just over that, it says NX _ density. So this is an object attribute that's being populated inside this note. If you want to add an attribute to your notes, all you have to do, I'll jump back down here and I'll type tab and then colon. And now if you want to add an attribute here, all you have to do is go back up to the main toolbar, the note general toolbar here, and you can go ahead and you can add a part attribute. So in the insert group, you'll see part attribute, hit the drop down. There's part attribute, and we also have an object attribute. Part attribute would be any attributes that are at the drawing level here inside of the attribute1 drawing file. I want to get an attribute from a part, another part. So I'm going to go down into the drop down. I'm going to choose object attribute. I'm going to click on that, and now you want to select your target object. I'm going to come over to the assembly navigator and select the attributes _1 part file. Once I do that, it opens up the attributes dialog and shows me all the attributes inside of the attribute1 part file. Now I can go ahead and choose the attribute that I want to pull the information in from. So I'm going to choose the tab _ type and then select OK. Now you can see the number 1 is showing up. You can see over inside the note dialog box here, we have that gray background behind the number 1. If I put my cursor on that, you can see the object attribute is being pulled in and it is the tab _ type attribute. Therefore, if I close this now, we jump back over to the attribute1 part and we go into File, Properties, and we set this tab type to a different number like tab 2, hit the check mark and select OK, and go back into the drawing now. In the part navigator, you are going to notice there's a clock symbol here with an A on that. That indicates that we have an out-of-date drawing and an out-of-date sheet, and that's because an attribute has changed that's being referenced. All right, so now that we've established we need to update that, all you have to do is left mouse button click on the clock, and you can see the attribute has just updated for the tab type to the value of 2. For the density and the weight, these have not updated yet. If I go back over to the attribute1 part, I can go into File, Properties, and for the mass properties for this part, I'm going to click on the mass tab here, and I'm going to tell it to update the mass properties now by clicking on the Update Mass Properties Now button here. Once we've done that, we can see the mass is now approximately 15.7 pounds. Going into the Attributes tab, we can see our material information has not been updated yet because you do have to hit Apply here. And once you do hit Apply, you can see the mass properties are now being generated or recalculated for that part. Now we can select OK, and we can jump back into our attributes1 drawing file. We can go ahead and update that. You can see we have out-of-date drawing, out-of-date sheet. And I can go ahead and click on the symbol here, left mouse button click, and you can see the density has been updated to 0.000 and then 7.13 here. All right, so with the density, you might want to go in and adjust that. It looks like we're not seeing a value there. It says pounds per cubic inch here. Edit the note. And then for that density, we can adjust the precision here if we need to do that. Now I'm going to go back out. I'm going to edit this. If you want to edit this, you can always go back in and change that attribute. So if you right click on that, you can go into replace here. And now I can select the target object, which is going to be attributes underscore one part. And I'm going to scroll down to the mass property density here and click on that. So I'll select OK. And same with the weight. If I want to update that one or change that, I can right click on that. We can replace that, go out to the attribute one, and then we can go down to the mass property mass here. All right, so I'll go ahead and close that out now. Now for this particular one, let's go ahead and update that as well. If I right click, go to precision, you can see it's 4 places out now. You can right click on this, set the precision. Maybe I want to go back to 2 places on that, or we'll just set that back to 3 again. And I'll go ahead and close this out. All right, so that's how you can adjust or add attributes to general notes on your drawing. If you change something with that attribute in the actual part file now, these general notes will update. Again, you might see when you go to your part navigator, it does have a little clock indicator. Just left mouse button click on that, and it should update the information here. Additionally, with attributes, you can do things in title blocks. You can put an attribute for a name. If I go into the drawing file here, and we go up to File and go down to Properties, you'll note inside this drawing file, we do have a drawing signature category here with drawn by. All right, drawn by B. Smith. And so if I select OK here, if we look at this title block, if I right click on that and we go to edit definition for the title block, and then we go into edit the table for that title block. For this particular section, drawn by, if I right click on that, we can go ahead and we can edit the cell or go in and do the settings edit here. Go in the common, go in the cell, and I'm going to right click here. To import an attribute into a cell, you do have to do something a little bit different here. So you'll go into import and you'll see attribute right here. So if you want to import an attribute into a cell of a table here, in this case we have a title block table, I'm going to right click on that cell and go to import, and you can see attribute option right here. If I click on that, that's going to open up an option here to import attributes into that cell. Where do I want the attributes to come from? Attributes from one object, attributes or work part attributes, attributes from all objects, or attributes from part and all objects. If I do attributes from the work part, you can see we have a drawn by attribute here. I can click on that, and then we can select OK here. Now you're going to get a note here that says the operation will cause existing cells to be overwritten. Do you want to continue? I'll say OK. And now I have my B. Smith or my drawn by attribute with the value for that attribute showing up inside the cell. If we finish out this operation, I'm going to go back up to my toolbar here, click on finish, and then click on defining the title block. Now I'm done doing that. Now if I go into edit the attribute inside this part, we go to File, Properties, and then we change the drawn by attribute here value to a different name, and then select OK. You'll see my name now shows up in the drawn by cell here inside my title block. So that's just another example of how you can use attributes to populate title blocks. All right, so that is attributes. That is controlling a design configuration with attributes, controlling information that shows up in your general notes on your drawing. And these are just a couple of different examples and benefits of using attributes inside your designs. That's going to conclude the Hidden Gems in NX CAD presentation here. Again, thank you for watching the presentation, and my contact information can be seen here on the screen. If you have any follow-up questions related to the topics covered here in this presentation, feel free to reach out and I can assist. Coming up next will be my colleague John Vincent to discuss Hidden Gems in NX CAM.
Hello everyone, and welcome to NX CAM Hidden Gems for this year's NX University event. In this session, we're going to take a look at complex setups for machine simulation. So this can mean a lot of different things, so we'll take a look at a number of items here today. We'll take a look at NX machine tool simulation as a whole. We'll look at our manufacturing setups, kind of traditional manufacturing setups purely from an NX CAM perspective. We'll take a look at the machine tool navigator and how items translate between your manufacturing setup and machine tool navigator. And then we'll look at preparing for simulation, and we'll do a little bit of a live demonstration, kind of putting to use some of these tips and tricks that we're going to talk about. So first of all, what is machine tool simulation? I'm sure there's plenty out there that are aware of what machine tool simulation is, but there's a few variants of it. So inside of NX, we can simulate pretty much any machine tool that you can think of, and not just limited to machine tools, but robots included. But we're going to largely be focused on machine tool simulation here. How does this really play into the digital thread, and what are really going to be some of the key benefits to the organization to leverage using machine tool simulation? So I want to start off by talking about kind of the levels of machine tool simulation, or different aspects of machine tool simulation. So historically, we've really had three variations. The first being toolpath animation. So that's what we're seeing on the left-hand side of our screen. This is where we're going to go ahead and kind of drive the tool. We're not going to pay attention to any machine kinematics. It's purely the internal toolpath inside of NX. And we're looking at the part geometry and tool geometry. Kind of the next step in this progression is going to be to do a full machine tool simulation, but simulating, again, the internal toolpath. This is where we don't necessarily need any posted code. We're purely going to be looking at the internal toolpath, still looking at our part geometry and tool geometry, but we're adding in the kinematic model of the machine tool. So that's going to add in things like the limits of the machine tool, the types of rotaries or types of linear axes the machine tool may have. And then one step further on top of this is to simulate the actual NC code, the same code that your machine will run. So now, instead of looking at the internal toolpath, we're going to be simulating the NC code along with your part geometry, tool geometry, and the kinematic model of the machine. So this is kind of getting to the highest level of simulation that we're going to talk about here today. And the big benefits here are this is getting close to being a one-to-one digital twin of your machine tool. And when I say that, I mean things like any auxiliary type functionality, tool changers, if we're doing mill turn machines, maybe part transfers, some complex machinery has the ability to reorient parts. When we're simulating our NC code, we can handle all of these things inside of NX CAM. So when we think about our end-to-end digital thread, there's a lot of aspects that come to play, and we're kind of going to be touching on two portions of this today. The first being just general manufacturing. So here, setting up our CAM file, laying out our tool paths, selecting our tools, specifying our part geometries, blank geometries, kind of the core functionality of CAM software. Now, regardless of what type of machine we're working on or how we generated these tool paths, we're going to want it to simulate these tool paths. And that's where NX Machine Tool Simulation module comes into play. And this works hand in hand with post-processor as well, because, again, different levels of simulation can utilize the posted code. My preference certainly is to utilize the posted code. It's the most accurate variation of simulation that you can get. So let's talk about that a little bit. What does that really mean here? So we have a couple images up on the screen right now, and we're taking a look at the same toolpath, both from the animation standpoint, where we can see that our tool is going to cut the part the way we programmed it. We can see how the tool is tilting. It's really orienting the tool based on the part geometry. Whereas in simulation, we get to see what's really happening on the machine tool. In this case, that we're seeing on our screen here, we might realize that our spindle face is much closer to the part than we really anticipated. Or maybe we actually have a collision, and with animation we're not going to catch that, but we will catch it with simulation. So we're getting some benefits just that we're able to really validate our NC code offline. So this is all in the digital world before it hits the shop floor. The last thing we want to do is get the programs out there, have the operators set everything up, and go to start the program, and all of a sudden they start running into problems. Over travels in the machine, syntax error in the code, crashes of the machine. So as we get into more advanced levels of simulation, again, we can simulate all the different aspects. So any kind of macros, subroutines you want to run on your machine tool, we can simulate all those behaviors. We're going to reduce or eliminate damage to our machines by doing any kind of crashes. And of course, we're going to be able to save a lot of time with being able to eliminate doing any dry running or kind of proving out the program at the machine tool. We're going to really have a validated program by the time we get to the machine tool. So there's going to be some caveats across different types of simulation, different types of machine tools that we're looking at. So just to mention a few here, NX Machine Tool Simulation does require a separate license. Now this license is included in some bundles, so you have to take a look at your license bundles to make sure you have this functionality to access Machine Tool Simulation. If you're using the toolpath-based simulation, there's some limitations there that we can only simulate single channel machines, and we can only simulate single setups of machine tools. So what does that mean? Mill turn machines that have an upper spindle, upper turret and lower turret, or B-axis upper and a turret on the bottom side of the machine. We cannot support those during toolpath-based simulation because we're not synchronizing those axes. That gets done with the post processor. And we can't do the multiple setups just because we don't have a way to deviate our different setups to that part file. And we'll talk more about that in detail here later. Additionally, multi-tools are not supported with machine tool simulation. Multi-tools, like we're seeing on the screen here, are where we have two different types of tools integrated into one. So this example, there's a turning tool with a roughing insert and a finishing insert on it. So we can minimize the number of tool changes, maybe for machine tools that don't have maybe the largest tool magazines. You can leverage these types of tools to really fit more functionality into the equipment you have. But these are some things that are supported in NC code simulation, machine code based simulation, not toolpath based simulation. So in any of these scenarios, you'll see this message that pops up if we encounter a scenario that's not supported. NX is going to try to force you into machine code based simulation, and as long as you have a valid post processor and a fully defined kinematic model, all will be good. I think if you have that, you'll likely be using machine code based simulation without exception. All right, so now this gets into kind of the core NX CAM setup information, manufacturing setup information. How can we have maybe multiple setup configurations, machine configurations, where and why do we get this information? How does it kind of flow through our CAM part file from our manufacturing setup to our machine tool simulation? So again, we know that there's a lot of different types of machine tools out there. Some of the basic ones that most companies have some exposure to or experience with are going to be your 3, 4, 5-axis milling machines, turning machines, and then getting into more things like turn mill, mill turn machines. Again, we can handle all these different scenarios inside of NX CAD. Now our setup configurations here, different ways that we can set up parts. This is something that's kind of ever-growing technology. Things like tombstones. Obviously, tombstones have been around for a long time, but we can nest a lot of different parts onto one tombstone, and they could be multiple iterations of the same program or same operation done at multiple sides of the tombstone, or maybe we have some parts nested onto one side of the tombstone that represent the first operation, next side of the tombstone has the second operation, so on and so forth. But now we're getting into more and more machines that have alternative methods. Mill turn machines, again, we can do part transfers, bar pull scenarios where we're going to pull the stock out a little bit, whether it's with a sub-spindle or with a bar feeder. We can support any of these scenarios. Maybe getting to some kind of fixture plates or multiple vise setups, or again, kind of nesting more parts on your machine tool, or tombstone vices. Sorry, not tombstone vices, pyramid vices. Kind of a later trend that's come out for 5-axis machines. Another way to nest more parts into one setup, get more spindle utilization out of your machine tools, with relatively little effort from the programming standpoint. So regardless of what type of approach or machine setup you're looking at here, the concepts are going to be the same that we're going to address today. So let's take a look at machine tool setup information here. So manufacturing setup information. Most of us are probably aware of the kind of the core functionality that we're going to specify things like our part geometry, our blank geometry, maybe check geometry. It's also fixture geometry. And that's kind of what this slide is dictating. That we have kind of our vise, our part, our blank, and the vise or fixture could be any number of things. Get vise, fixture plate, tombstone, pyramid vise, whatever you like there. But something we really need to do is to be able to transfer our stock condition from one operation to the next. So that gets into, how do we really kind of track that IPW and transfer it from setup to setup? Well, let's take a look at, again, first our cam level geometry. So instead of our cam setup, again, likely familiar with this dialog instead of our workpiece, where we're going to specify that part geometry. Again, that's just going to be our design part. Typically, a solid body is going to be the most common geometry that we're going to be utilizing. And then our blank is going to be created any number of ways, whether it's just some billet stock that we're using. So we might use a bounding body, bounding block, bounding cylinder. It could be geometry that we're creating from or representing a casting or a forging with, or any number of different settings in here. Again, we'll take a look at some more advanced level ones like the IPW workpiece here in a little bit. And then lastly on this slide, we're going to take a look at check geometry. Again, check geometry is just another term that we use for any non-cut geometry. Typically are fixtures in most cases, but it can be used in other scenarios as well. So now we want to understand, how does this really transfer from NX CAD into the machine tool environment? As we know, NX is a very integrated system, so it's going to happen quite seamlessly. However, there are some caveats, especially some complex setups of what you need to do as a programmer to make these different setups work a little bit more smoothly. And that's what we're going to kind of take a look at here shortly. So the interesting thing is that all the data that we're kind of specifying in our geometry view inside of NX CAD kind of needs to get replicated inside of our setup configurator. And setup configurator is part of the machine tool navigator. And this is at, again, the machine tool level really coming from Machine Tool Builder, where we define all the kinematics of the machine. So how do the axes move? What axes are built on top of other axes to have that kind of parent-child relationship? So whoever builds your simulation kits, whether you do them internally at your company or you purchase them from a third party or get them from Host Hub that Siemens provides, the functionality really works the same here. So we're defining the kinematics of the machine tool. That's where we also define all the axis limits, the acceleration and deceleration rates of the machine axes for getting very accurate cycle times when we use them for simulation. And so now we want to kind of tie these together. So to understand how we do this, we're going to take a quick look at Machine Tool Builder and what we call component classification. So we build out the machine tool with all the different linear rotary axes, but we also specify some setup information. And there's really three setup elements that we are going to be focused on here. One is just a general setup element. Just means it's part of the setup. For instance, our fixture doesn't get anything other than a setup element assigned to it, but our part geometry and our blank geometry get additional classifications. And these are really going to be kind of pointers to say, well, I want to inherit my geometry from my CAM operation, from the geometry view, my part, my blank, and my check geometry into my setup configurator. So my part geometry is going to be paired with my part classification. My blank geometry is going to be paired with my workpiece classification. And my check geometry is going to be tied to the setup element classification. So now we can take a look here at this example where we have a little bit of a customized setup for our simulation inside of the Machine Tool Navigator setup configurator. In this case, we have 4 setups going on in this part. There's 2 that are kind of the first operation on one side of the tombstone. And then on the adjacent side of the tombstone, there's the second operation. So this is what we're really looking at now. Is how do we map these things together? How do we get all this information to inherit properly when we're using multiple setups, multiple orientations of our part geometry, and our IPWs? So that's kind of how we can start creating multiple setups and be able to, inside of the NX CAD geometry view, specify what setup configurator setup do we want to tie this material to, because we can't tie all the geometry if we have multiple workpieces to one setup element. It just doesn't work. So we'll show here in a little bit exactly how to do that. I'll go through the steps in a live demo here. But before we get there, we're going to get into the last topic here about just preparing for our simulation. So again, we started to understand that we're going to, in this scenario, have multiple setups. So again, in the first example that we're going to take a look at, we'll have a program completed for the first operation. We'll have a program completed for the second operation. How do we make sure things are mapped out correctly? And then how do we tie that into nesting for multiple parts? We want to really easily be able to reuse that information. So with the work pieces inside of NX, we'll end up having 4 work pieces, 1 for each setup, and we have to map some of the blank geometry. Obviously, the initial operations, we're just going to be looking at, in this scenario, using a bounding body from, say, some billet material. But then we want to pass that IPW to the second operations. And for that, we will take use of the IPW workpiece blank type. So when we bring in a machine tool kit from our library, there is going to be this setup element that we talked about earlier. And this is where we kind of have some placeholders, and those items are classified to inherit from our part geometry. Now, if we want to take a look at adding additional setups, we can do that. So in the scenario that we're going to go through here in a moment, we're actually going to have 4 setups in our part file. So we need to have 4 setup elements inside of our setup configurator as well. So if you're doing a lot of this type of work, you might want to have some machine kit files set up for single station or 4 station or 8 station, depending on what's really kind of normal for your behavior. So you don't have to do this every time. And in the end, we're just going to be mapping our work pieces from the operation navigator in the geometry view to the setup configurator and the various setups that we create to kind of a one-for-one match here. And once we have that, we'll be able to define which workpiece connects to which setup configuration via the physical workpiece. Once we toggle on the physical workpiece, we can choose and inherit the appropriate setup from this pull-down menu that is dynamic. It's looking at the setup configurator and analyzes how many setups are really available there and allows you to assign the geometry appropriately. And lastly, we'll see this slide just kind of shows us, yes, how we do this mapping between the two. But we're going to go through that live in just a moment. So the physical workpiece, again, this is a little bit of a newer option. It's not in the, it didn't come out just in these releases, but within the last handful of releases, we've had this now. And it really aids in our ability to do just this. These complex setups, multiple orientations of how the part is going to be tracked. Lathes, again, bar pull scenarios or bar fed lathes makes it very easy for us to be able to handle these types of setups. And the last thing we're going to look at, and I'm going to show this again in the live demo, is how do we capitalize on having these redundant kind of nested parts inside of a given operation and take use of having that operation program one time and just apply it in multiple areas. Because we certainly don't want to program the same part multiple times just because it's going to be multiple instances of it on some sort of a fixture plate. All right, so let's go ahead and dive into that. So here we are in NX, and now we're going to take a look at what does kind of a standard setup, how does it function, what might you see if you try to do a complex setup like this without properly setting up your setup configurator inside of NX. So I do have a machine tool loaded here. It's suppressed right now, but you can see I have a 4-axis machine. This is one of the out-of-the-box kits that's made available in NX with the installation. But taking a quick look at what do we have so far. So here, programmed on the first side, we have op1, we'll call it. Here on the left-hand side of my screen, all these operations, finishing that part. And then we're coming to op2 on the right-hand side of this tombstone and doing the remainder of the geometry. So this was done by having a couple workpieces. Again, my workpiece front 1, we can see that, yes, I'm using this part geometry and the blank geometry and the fixture geometry or check geometry. And then the IPW will show here that, yeah, we're using the, again, part geometry. But then the next step is the blank geometry. How do we get our IPW? Let me rotate around here. How do we get the IPW from the first operation over here? We're not exporting any geometry. We're not exporting out like an STL and then positioning it. The trick here is using the functionality of IPW instead of the blank geometry. So what this allows me to do is I can specify, in this case, I'm looking at my current work part, so the piece that I'm working on right now. And NX knows that I have 4 work pieces available here inside of my geometry navigator, and I can pick what is the here I can pick what is the setup that I want to inherit that geometry from. So in this case, yeah, we're just going to select the front workpiece front 1, and that allows me to update this IPW. Let's go ahead and do that. We'll update from the IPW source. Now we can see the status is up to date down here at the composite IPW. And as I did that, the operations attached to that geometry went out of date because, again, it updated the geometry. So I can go ahead and just regenerate these operations. So now, next, we'll take a look at the simulation of this. How does this work with kind of the automatic inheriting of these operations? Or sorry, how does that work with the automatic inheriting of the geometry into the setup configurator? So before we take a look at it inside a simulation, here's our machine tool navigator setup configurator. And if I expand all, we can see that I have one setup element here with a fixture, a part, and a blank. I don't want to spoil it here, but we're going to need more because we can't inherit 4 different setups into one setup element. But let's take a look and see what this does look like when we try to simulate it. Let's turn our machine back on, and we can go to Simulate Machine. And we've initialized our simulation. Let's go ahead and turn on our material removal. All right, so now that was our first indicator that something might not be quite right. We only see the blank appearing from the initial operation, the initial setup here. And if we go through, we can see maybe there's going to be a few other things that might not be quite right. Currently, we're seeing, we can see setup 1 and setup 2 moving around, but the tombstone's not moving. The other setups aren't moving. So this is all tied to, what can we really inherit automatically? And in our case, certainly was not enough information. So let me go ahead and stop this. And what I would really do now is I would go into my setup configurator. I would add some additional elements here. So maybe I would come in to add a machine component, and they set up 2. Oh, I didn't want to rename that. Let me undo that. Insert a new element. Set up 2. And now I could insert additional new elements. Fixture 2. And use our classify components to select this as a setup element. I would also want to select the setup 2 as a setup element as well. And so on and so forth. So I have another part file ready to go here just to save a little bit of time. Exactly the same toolpath, same setup, everything going on here. With the difference being that in my Machine Tool Navigator setup configurator, we can see that I have multiple setups. So I have my setup front 1, setup front 2, setup right hand 1, setup right hand 2. And then I have one element for my fixture. I kind of broke that out to include all the fixtures in there. So the way that this is going to work now with these new elements created, when we look back in the Operation Navigator in the Geometry view, and I edit my workpiece, I'm going to go through and toggle on the Physical Workpiece option. Because right now, NX is going to take anything that's assigned to the part and try to apply it to the setup configurator, whatever element is defined as part. Well, by toggling on Physical Workpiece, I can now differentiate what setup do I want this to belong to. So now I'll choose my setup 1 front 1. You can see I get a little green icon here now that's indicative of having physical workpiece active. And I'll do this for each one of my setups. So again, setup front 2, setup right hand 1, and finally setup right hand 2. So now this is going to map all the geometry selections from the Operation Navigator geometry view into the machine tool setup configurator. Additionally, we had already done all of our IPW transfers and things of that nature. So my part is all good to go as far as how it's programmed. Let's go ahead and turn our machine on. And now we can take a look at the difference of simulation here. All right, so let's go ahead and initialize our simulation. And we can see that we are defaulting to machine code-based simulation. If I were going to jump to toolpaths-based simulation, we'll see that we will get this message. Selected operations have multiple workpieces. This is not supported in toolpath-based simulation. Only one IPW will be created. So let's maintain using machine code-based simulation. Anytime you do this, it's running the post processor right now to go ahead and generate the code. Or it will also inherit the code if it's already been attached to the operations. All right, so now let's take a look. What do we have here? Turn on our material. All right, we see both of our IPWs have been created. Let's go ahead and start our simulation. All right, so we are running through materials being removed from Op1, the first setup that we're taking a look at here. And we'll just let it go through kind of quickly, rough out this part, finish it, and then we'll be able to see that, yeah, we'll move on to the next operation to go ahead and look at doing all this inside of one program, one part file, or one set of NC code. So this might take a little bit. Maybe we'll just jump ahead. And I can at any point in time pick on different portions of the toolpath, different portions of the geometry, and now we'll see that, yeah, we'll have our ability to jump ahead, move the tombstone, and simulate the rest of that content. We'll take a little bit closer look at some of this stuff here in a second. But something important I want to touch on for these types of scenarios, let's turn those blanks off again. And how do we go ahead and reuse the toolpaths that we've already created on other operations? So yeah, you're probably used to the fact that yes, you can do transformations. There's also things you can do in a post to call out multiple work offsets and sub programs, and all those ways work. But we're going to look at it from the eyes of purely NX. We want toolpaths to be as associative as possible. We don't want to get too fancy in our post and try to manipulate these things. So what we're going to do in this case, we'll take a look at all of our initial operations here. Actually, I'm going to jump over to the geometry view. And I'm going to copy these operations. And now I'm going to paste them into the MCS for the second setup. And when we have this, we have the option to do paste inside with reference. With reference is the key here. So this is going to allow us to have multiple MCSs. We could even have different orientations and things like that. But wherever the MCS goes, the toolpath is going to go. So as I move the secondary op, maybe I need to move the setup over for clearance purposes or put it on the other side of the tombstone. All of these operations are tied to the initial operations. So if I change the initial one, it's going to change the reference operation. But really the unique thing here is the ability to have multiple MCSs under multiple setup groups, workpiece groups to enable this type of behavior. And I'm going to do the same behaviors here, the same selections for the secondary op. Let's go ahead and copy and paste inside with reference. And there we get our secondary ops for our right hand part. And you'll see, interestingly, it organizes everything by tool. So we're going to grab our first tool that we're roughing with for op 1, and we're going to process the first part and then the second part and jump back and forth like that. So it's a nice, efficient way to execute this program. So let's go ahead and just kind of run through this simulation. All right, see, we have all 4 of our blanks made available to us. Post is running through, generating the code. Clean up our windows a little bit here. I might just let that tile close, and we can see, let's window around here, we are using our IPWs that we transferred based on our geometry groups. So we'll get an accurate representation of what's going to happen with this material removal when we get to those operations. All right, let's go ahead and just play this through. And there we have fully programmed and simulated part for 2 operations, nesting 2 operations each on the tombstones there. With that kind of covers how we would recommend programming operations like this. And I want to thank you for spending some time with me here in NX CAM Hidden Gems. Take care. Thank you.